Imagine stepping outside on a day that seems perfectly ordinary. The sky is clear, the air is calm, and everything feels as predictable as it always has. Now picture that tranquility shattering in an instant. The clouds darken without warning, the wind howls like something out of a nightmare, and nature unleashes a spectacle so bizarre, so utterly unexpected, that it defies everything we thought we knew about the weather. This isn't just a storm or a heat wave. This is something far stranger, something that feels almost otherworldly. Across the vast and varied landscape of the United States, moments like these have unfolded time and again, leaving witnesses stunned, communities transformed, and scientists scrambling for answers. These aren't merely weather events, they're reminders that nature still holds mysteries we can't fully explain, no matter how advanced our technology becomes. From sudden tornadoes spinning out of nowhere to freak blizzards burying spring flowers in snow, America's meteorological history is filled with chapters that read more like science fiction than fact. There was the day it rained frogs in Arkansas, the time a town in Minnesota was coated in ice so thick it looked like a glazed wonderland, and the strange summer when temperatures plunged so low that frost formed in the desert. Each of these events carries a story, a moment when the ordinary rules of climate were tossed aside and replaced with chaos, wonder, or sheer terror. They challenge our understanding of the atmosphere and invite us to look closer, to question what we think we know, and to marvel at the raw, untamable power of the world around us. In this video, we're going to journey through some of the most unbelievable weather phenomena ever recorded on American soil. We'll explore events that sound too wild to be true: downpours of fish, skies turning green, hurricanes that behaved in ways meteorologists still debate. This isn't just a list of oddities, it's an invitation to witness the moments when reality seemed to bend, and nature showed us a side of itself we rarely get to see. So settle in and open your mind to the extraordinary, because what you're about to discover will leave you in awe of just how unpredictable and how utterly fascinating the weather can truly be. Our journey into America's strangest weather kicks off in the industrial city of Cincinnati, Ohio, during the famously brutal winter of 1977. It was a season defined by record-breaking cold and relentless snowstorms, a time when the entire Midwest seemed locked in a deep freeze. But on one particularly frigid day, the citizens of Cincinnati witnessed something that would transform a typical winter hardship into a scene from a surreal fairy tale. As the snow began to fall, people quickly noticed it wasn't the pure white blanket they were accustomed to. This snow was undeniably, vividly blue. Streets, cars, and rooftops were soon covered in a layer of sapphire-tinted ice crystals, turning the entire city into an eerie, azure landscape. The explanation for this bizarre phenomenon was as grounded in industry as it was unexpected. Investigators quickly traced the source to a nearby textile factory. A common dye used in their manufacturing process, a striking blue pigment, had somehow been released into the air. Meteorologists later pieced together the perfect storm of conditions that allowed this to happen. A heavy, wet snowfall moved through the area just as the dye particles were emitted from the factory's vents. The snowflakes forming in the saturated atmosphere acted like tiny sponges, collecting and encapsulating the blue dye particles as they fell toward the ground. The result was a precipitation event that was equal parts pollution and natural wonder, a literal coloring outside the lines drawn by nature. The public's reaction was a mixture of sheer bewilderment, delight, and no small amount of concern. Children dashed outside to play in the alien-looking substance, while adults scratched their heads, unsure if the colorful snow was a harmless novelty or a toxic hazard. The event instantly became a local legend, a story passed down through families about the time winter decided to experiment with a new color palette. While officials eventually confirmed the dye was non-toxic, The Great Blue Snow of 1977 serves as a powerful and peculiar reminder of how human industry can occasionally intersect with natural forces to create something truly magical and utterly inexplicable for everyone on the ground below. Only a few decades earlier and several states to the east, an entirely different kind of industrial weather anomaly unleashed a far more destructive and terrifying power. The year was 1910, and the stage was set in Ohio by a devastating combination of natural forces and human activity. A severe, prolonged drought had left the forests and fields of the region tinder dry, while coal mining operations had littered the landscape with massive piles of highly flammable coal dust and slag. For days, a pall of thick, acrid smoke from countless small fires hung over the area, a constant haze that blotted out the sun and made breathing difficult. Then, on April 17th, the winds arrived. Gale-force gusts whipped through the valleys, fanning those scattered fires into an uncontrollable inferno. But the event took its truly bizarre turn when the intense heat from the burning coal dust and the unusual wind shear conditions combined to create something almost unimaginable, a fire tornado. Witnesses described a massive, churning column of fire and black smoke roaring through towns like a biblical plague. This wasn't just a wall of flames moving along the ground. It was a vortex, a tornado made entirely of fire, leaping across rivers and roads with terrifying ease, consuming everything in its path with a roar that sounded like 1,000 freight trains. The devastation was absolute. Entire towns, including the community of Carruthers, were completely wiped off the map. Homes, businesses, and schools were reduced to ash in minutes. The intense heat was so overwhelming that it melted glass and twisted metal railroad tracks into grotesque, unrecognizable shapes. People fled for their lives, many with only the clothes on their backs, as the firestorm moved faster than a person could run. The official death toll was heartbreaking, but many historians believe the true number was likely higher, lost to the chaos of the event and the complete destruction of whole communities. The Great Ohio Firestorm stands as a horrifying example of what can happen when the raw power of nature is amplified by industrial carelessness. It was a freak weather event born from a perfect storm of drought, wind, and immense readily available fuel. This wasn't a simple forest fire. It was an atmospheric phenomenon of fire and wind, a terrifying spectacle that demonstrated how human industry could inadvertently conspire with the climate to create a new and monstrous form of disaster, the memory of which would scar the region for generations. If the devastation of the Great Ohio Firestorm showed nature's terrifying fury amplified by human activity, the events of 1816 demonstrated a far more unsettling concept: the entire climate of a continent thrown completely out of balance by a disaster on the other side of the world. To understand the year without a summer, we have to begin not in America, but on a remote Indonesian island called Sumbawa. There, in April of 1815, the volcano Mount Tambora unleashed the single most powerful volcanic eruption in recorded human history. The explosion was so colossal it was heard over 1,200 miles away, and it instantly killed tens of thousands of people. But the most profound effects were yet to come, as Tambora fired an immense plume of sulfur dioxide and fine ash high into the stratosphere, creating a vast aerosol veil that began to slowly drift across the globe, blocking and reflecting sunlight back into space. It took nearly a year for this volcanic shroud to fully encircle the planet and exert its maximum chilling effect. By the spring of 1816, New England farmers were growing deeply anxious. The weather was unseasonably cold, but they held out hope for a late thaw. Those hopes were utterly dashed in June. A series of brutal winter storms slammed into the northeastern United States, bringing heavy, wind-driven snow and killing frosts. In Vermont, accumulations reached a shocking 20 inches. In Massachusetts, a 4th of July celebration was held under a sky so cold that men reportedly huddled around bonfires for warmth. For a society almost entirely dependent on agriculture, this wasn't just an oddity, it was an existential catastrophe. Corn stalks froze in the fields, wheat crops failed entirely, and fruit trees that had just begun to blossom were killed by the relentless frost. The social and economic consequences were immediate and devastating. The price of staple grains like oats and wheat skyrocketed, in some places increasing by over 700%. Stories from diaries of the era tell of farmers feeding their livestock boiled nettles and sawdust because there was no hay, and of families grinding up old corn cobs and bark in a desperate attempt to make flour. Widespread famine set in, followed by disease. The psychological impact was equally profound. In an age before modern meteorology or global communication, people had no scientific explanation for why the sun had seemingly lost its power. Many turned to religion, interpreting the endless winter as divine punishment. Others blamed sunspots or unusual ocean currents. It was a period of profound fear and superstition, a collective trauma that forced a fundamental rethink of humanity's relationship with the natural world. Perhaps the most significant long-term impact of this freak weather year was on American migration patterns. For thousands of families struggling to survive on unproductive, frost-bitten farms in New England, the only logical choice was to leave. This provided a massive new wave of settlers headed westward, accelerating the push into the more temperate and fertile lands of the Midwest and Ohio River Valley. The year without a summer, a weather event born from a geological cataclysm half a world away, didn't just ruin one growing season. It actively helped reshape the demographic and agricultural map of a young United States, proving that sometimes the strangest weather events can alter the course of history itself. Leaving behind the global chill of the year without a summer, our next event showcases a meteorological surprise on a much more local, yet no less surreal, scale. It's difficult to picture a scene more contradictory to a frozen New England than the sun-drenched, palm-lined coast of San Diego, California. For its residents, winter is typically a season of mild, pleasant days, not frosty mornings. Yet on January 10, 1949, the city's entire identity was temporarily turned upside down in a matter of hours. The day began cool and overcast, which was unusual enough for San Diegans, but nothing could have prepared them for what came next. Shortly after 10 in the morning, the sky didn't just release rain, it began to pour snow. Not a light, fleeting flurry, but a genuine, heavy snowfall that accumulated faster than anyone could believe. The meteorological setup for this freak event was a perfect, if bizarre, alignment of conditions more common to the Rocky Mountains than the Pacific coastline. A powerful and unusually cold low-pressure system had barreled down the California coast, pulling in vast amounts of moisture from the ocean. At the same time, a mass of frigid Arctic air managed to plunge deep into Southern California, lowering temperatures to near freezing levels at the surface. The real key, however, was the extreme cold present just a few thousand feet up in the atmosphere. As the moist ocean air was forced to rise over the coastal mountains and the cold air mass, it created lift and condensation at an altitude cold enough for snow to form. This snow then fell through a shallow layer of above freezing air at the surface. Normally, this would melt into rain, but on that day, the snowfall was so heavy and intense that it simply didn't have time to melt completely before it reached the ground, a phenomenon meteorologists call dynamic cooling. The result was a spectacle that seemed pulled from a dream or a movie set. For nearly an hour, heavy, wet snowflakes swirled around palm trees and landed on sun-bleached beaches. Children who had only ever seen snow in picture books ran outside to build slushy snowmen on their front lawns, while equally astonished adults watched from their doorways, shaking their heads in disbelief. The iconic landscapes of Balboa Park and Mission Beach were transformed into a temporary winter wonderland, with a half-inch of white accumulation dusting tropical plants and Spanish-style rooftops alike. The snow was too warm and wet to last long, beginning to melt almost as soon as it stopped falling. but for that brief window, San Diego became a place of magical contradiction. Beyond the initial wonder, the event had very real, if temporary, consequences. The weight of the wet snow, however slight, was completely unexpected for the region's infrastructure. Tree branches, unaccustomed to any such burden, snapped under the weight, and power lines swayed dangerously. Traffic, unsurprisingly, came to a complete standstill. San Diego's fleet of roads departments had no snowplows, and its drivers had no experience navigating snowy roads, leading to a spate of minor fenders benders as cars slid through intersections. The Sunshine Snow of 1949 remains a legendary outlier in the city's recorded weather history, a one-in-a-million event that proved even the most predictable and tranquil climates are not immune to nature's capacity for the utterly unexpected. It serves as a cheerful reminder that the atmosphere holds onto its ability to astonish us, capable of bringing a moment of winter magic to a place where summer never seems to end. While a sudden snowfall in San Diego was a surreal spectacle, our next event represents something far more grim and terrifying, a force of nature so powerful and relentless that it redefined our very understanding of tornadoes. On the morning of March 18, 1925, the weather across the Midwest seemed unremarkable, even unseasonably warm for late winter. But beneath that calm surface, atmospheric conditions were aligning to create a monster. Just after 1 in the afternoon, a funnel cloud descended near the town of Ellington, Missouri. This was no ordinary tornado. It would soon be recorded as the single deadliest and most longest-tracked tornado in American history, an event so extreme it was once thought to be meteorologically impossible. The statistics of the tri-state tornado remain staggering even a century later. It stayed on the ground continuously for a staggering 3.5 hours, carving a path of total devastation 219 miles long through southeastern Missouri, southern Illinois, and southwestern Indiana. It moved at an astonishing forward speed of over 60 miles per hour, giving towns in its path mere minutes of warning. At its peak, the funnel was estimated to be nearly a mile wide, a churning black mass of debris and wind so powerful it obliterated everything in its wake. The scale of destruction was absolute. Entire towns were simply erased from the map. In Murfreesboro, Illinois, the tornado cut a swath through the city, killing 234 people alone and leaving over 1,000 injured. In West Frankfort, a mine elevator shaft became a tomb for dozens of workers who rushed into it for shelter, only to be killed by the intense low pressure and flying debris that filled the shaft. What made this tornado so uniquely baffling to meteorologists for decades was its behavior. Unlike typical tornadoes, which are associated with classic supercell thunderstorms and often dance across the landscape in a discontinuous path, the tri-state tornado was a relentless, continuous ground tracker. For years, scientists struggled to understand how a single tornado could maintain its integrity and ferocity for so long without lifting. The prevailing theory now suggests it was fed by an unusually stable and powerful inflow of warm, moist air directly from the Gulf of Mexico, which was channeled into the storm's circulation without interruption. It essentially created its own perfect, self-sustaining environment, riding a narrow atmospheric highway for over 200 miles without ever weakening. The human stories from that day are a harrowing tapestry of tragedy, quick thinking, and sheer luck. Survivors described a sound unlike any other, a deep, roaring rumble that shook the earth itself. Many reported a strange, pouring rain of mud that occurred just before the funnel arrived, as the tornado scooped up soil from nearby fields and dropped it ahead of the storm. The lack of a modern warning system meant most people had no idea what was coming. The official death toll reached 695, with over 2,000 injured, making it the deadliest tornado event in U.S. history by a massive margin. The aftermath was a landscape of utter ruin, with towns like Gorham, Illinois, and Griffin, Indiana, nearly completely annihilated, their populations decimated. The legacy of the tri-state tornado extends far beyond its grim statistics. It was a pivotal moment that forced a radical change in how we perceive and prepare for such disasters. Its unprecedented nature proved that our worst-case scenarios could always be exceeded, leading to greater investment in meteorological research and the eventual development of a national tornado forecasting and warning system. This single freak event, born from a perfect and terrible alignment of atmospheric conditions, demonstrated nature's capacity for focused, unimaginable violence on a scale never before seen, forever earning its place as one of the most extreme and consequential weather phenomena in recorded history. Just a few short years after the tri-state tornado redefined our understanding of localized destruction, the entire eastern seaboard was gripped by a weather event of such immense scale and contradiction that it left the nascent weather forecasting community in a state of both horror and profound fascination. Late in November 1950, most Americans were looking forward to a typical Thanksgiving weekend, anticipating perhaps a bit of seasonable chill but nothing out of the ordinary. What arrived instead was a meteorological monster, a storm so vast and powerful it would earn the enduring title the Great Appalachian Storm. This wasn't a hurricane or a simple blizzard. It was an extratropical cyclone of almost unprecedented intensity, a sprawling low-pressure system that behaved more like an atmospheric bomb, unleashing a bizarre and devastating combination of hurricane-force winds and record-shattering Arctic cold simultaneously across dozens of states. The genesis of this colossal storm was a freakish collision of air masses over the Ohio Valley, a mass of incredibly warm, moist air surging north from the Gulf of Mexico slammed directly into a wedge of incredibly dense, frigid air pouring south from the Arctic. This clash of titans acted like a starting pistol for rapid cyclogenesis, causing the barometric pressure at the storm's center to plummet at an astonishing rate. The resulting low-pressure system became so deep and powerful that it essentially created its own weather, pulling winds around it at speeds that rivaled a major hurricane. As the storm churned its way northeastward, it dragged that bitter Arctic air behind it, creating a wild and dangerous weather dichotomy. To the west of the storm's track, states were plunged into a deep freeze with blinding snow, while to the east, areas were battered by torrential rains and winds strong enough to peel roofs from buildings and push entire freight trains off their tracks. The human impact was as varied as the weather itself, a tale of two disasters unfolding side by side. In Ohio and West Virginia, communities were buried under as much as 4 feet of snow, with drifts piling up to 30 feet high, completely trapping residents in their homes and shutting down all travel and communication. Meanwhile, cities along the Atlantic coast, like New York and Boston, were lashed by wind gusts clocked at well over 100 miles per hour. The storm surge, combined with high winds, caused severe coastal flooding, sweeping homes off their foundations in New Jersey. The sheer force of the wind was utterly destructive. It toppled countless trees and power lines, leaving millions without electricity or heat in the rapidly falling temperatures. The death toll, estimated at over 350, and the incredible financial damage, which would be many billions in today's dollars, cemented its place as one of the most destructive non-tropical storms ever to strike the United States. For meteorologists, however, the most astonishing aspect of the storm was the weather map it produced. The isobars, those lines connecting points of equal atmospheric pressure, were drawn so tightly together around the intense low that they formed a near-perfect circular bullseye over the Appalachians. This indicated an extreme pressure gradient which directly explained the hurricane-force winds, but the map held another, even stranger feature. The entire circulation of the storm was counterclockwise, as expected, but this meant it was pulling frigid air from the north down into the southeastern United States in a massive and highly unusual surge. This caused places like Florida to experience freezing temperatures, while New England, typically colder, was on the slightly warmer side of the system. This backward temperature distribution, with cold air flooding south and east, created a weather map that veteran forecasters later described as one of the most beautiful and terrifying they had ever seen. The legacy of the Great Appalachian Storm of 1950 is immense. It was a pivotal case study that dramatically advanced the field of meteorology, forcing scientists to better understand the development and behavior of extratropical cyclones. The storm's unique structure and incredible power provided a textbook example of what the atmosphere is capable of generating under the most extreme conditions. It proved that a storm didn't need to be tropical to wield devastating hurricane-level force, and it showcased nature's ability to wield two opposing weapons, blinding snow and destructive wind, at the very same time. This event didn't just break records, it rewrote the book on how we perceive and prepare for large-scale winter storms, leaving an indelible mark on both the landscape and the science of weather prediction. When we think of tornadoes, our minds typically conjure images of the vast, flat plains of Tornado Alley, Oklahoma, Kansas, Texas, where the atmospheric ingredients for twisters come together with terrifying regularity. The last place anyone would ever expect to see one is amidst the sprawling freeways, palm trees, and sun-baked suburbs of Los Angeles. Yet on March 1, 1983, that exact impossibility became a shocking reality. The day began with the typical marine layer and mild temperatures characteristic of a Southern California early spring, but a potent and unusually positioned low-pressure system off the coast was already setting the stage for a profound meteorological anomaly. This system began pulling in significant moisture, not from the typical sources, but from a more subtropical flow, creating an unstable air mass right over the heavily populated LA basin. The first tornado warning from the National Weather Service was issued that morning for Orange County, south of Los Angeles, a rare enough occurrence in itself. But the true spectacle began just after 11:30 a.m., when the first of what would become a series of funnel clouds was spotted. Over the next several hours, no fewer than 7 distinct tornadoes would touch down across the region, from the city of Hawthorne down to Huntington Beach. The most significant, and the one that would permanently shatter the city's sense of climatic immunity, was an F2 tornado that tore through the neighborhoods of south-central Los Angeles. With winds estimated between 113 and 157 miles per hour, this was not a weak, dust devil-like spin-up. It was a genuine, powerful tornado carving a path of destruction through an urban landscape wholly unprepared for its arrival. The sight was utterly surreal. The tornado, a dark, churning funnel, was seen moving past iconic palm trees and low-slung stucco homes, sucking roofs off buildings, shattering windows, and hurling cars and debris through the air. It tore through a commercial area, devastating a furniture store and multiple auto body shops, reducing structures to piles of splintered wood and twisted metal. The sound was described by witnesses as a deafening roar, a freight train noise that is chillingly familiar to residents of the Midwest but completely alien to Angelenos. The chaos was compounded by the fact that few people initially recognized the danger for what it was. Many assumed it was some strange, intense windstorm or even an earthquake until they saw the unmistakable funnel. The immediate aftermath in South Central looked like a scene imported from another part of the country. Streets were littered with insulation, shattered glass, and the mangled remains of people's possessions. Over 30 buildings were damaged or destroyed, and dozens of people were injured, though miraculously, no one was killed. The response from residents and city officials was a mixture of shock and bewildered resilience. This was a disaster for which there was no playbook. The city's emergency services, drilled endlessly for earthquakes and wildfires, found themselves dealing with a problem they never anticipated. News helicopters, usually circling for traffic or crime reports, instead broadcast footage of a tornado's damage path snaking through the urban grid, a visual that seemed to defy all logic. For meteorologists, the event was a landmark case study. tornadoes in California are not entirely unheard of, but they are almost always weak, brief, and occur in rural areas. This outbreak was different. The scientific post-analysis pointed to a highly unusual confluence of factors. A strong jet stream provided the necessary wind shear, while the low-pressure system created ample lift. But the real key was the presence of unusually high moisture and instability for the region, ingredients that typically stay far away from the Pacific coastline. This combination overrode the stabilizing influence of the cool ocean and created a narrow window where the atmosphere could behave as it does over the Great Plains. The 1983 outbreak forced the National Weather Service to completely reassess the tornado risk for the entire region and drastically improve its warning capabilities for Southern California. Beyond the charts and the data, the event left a deep psychological imprint on the city. It was a powerful reminder that nature does not respect our preconceived notions or geographical stereotypes. The perception of Los Angeles as a safe haven from violent tornadoes was irrevocably broken that day. It proved that even in a place defined by its sunshine and seismic faults, the sky could still unleash a kind of fury its residents never thought they'd have to face. The Los Angeles tornado outbreak stands as a profound example of weather's ability to defy expectation and rewrite the rules, delivering a Midwestern nightmare to a West Coast metropolis without any warning at all. While the Los Angeles tornadoes defied geographic expectations, another event proved that some of the most ferocious and deadly storms can occur not over land, but over vast bodies of water, invisible to most until it was far too late. For sailors on the Great Lakes in November of 1913, the end of the shipping season was always a race against time, a final push to deliver one last load of coal, iron ore, or grain before the ice closed the ports for the winter. The 5 immense inland seas were already infamous for their sudden, violent squalls that could churn up waves to rival the ocean. But what arrived that month was something else entirely, a storm of such biblical fury and duration that it would forever be remembered as the White Hurricane, a blizzard that didn't just rage on the lakes, it became one with them, unleashing a chaos so complete it was nearly impossible to survive. The storm's opening act was deceptively mild. On November 7th, a shallow low-pressure system brought some rain and gusty winds to the region, nothing the seasoned lake captains hadn't seen countless times before. The real horror began 2 days later when this system was violently energized by the collision of 2 extreme air masses. A mass of warm, moist air surging up from the southern plains slammed directly into an immense, dense wall of Arctic air plunging down from Canada. This collision over the lake basin acted like a meteorological trigger, causing the pressure to plummet and the storm to explosively intensify into what modern meteorologists would call a weather bomb. The resulting cyclone stalled directly over Lake Huron, its counterclockwise circulation pulling in Arctic air from the north and lake effect moisture from the south, creating a perfect self-sustaining engine of destruction. For the next 4 days, the storm unleashed a multifaceted assault that was virtually inescapable for anyone on the water. Hurricane-force winds, sustained at over 70 miles per hour and gusting much higher, whipped the lakes into a seething frenzy. These weren't ordinary waves, they were monstrous, chaotic pyramids of water, some reliably estimated to be over 35 feet high, crashing into ships from all directions with unimaginable force. But the wind's most bizarre and deadly effect was the creation of freshwater seas, a phenomenon where the spray from these massive waves was instantly frozen by the sub-freezing air and plastered onto every exposed surface. Ships became top-heavy, encased in ice several feet thick, their decks transformed into treacherous, sloping glaciers. This immense weight made them unstable and prone to capsizing, while also freezing their navigational equipment and sealing their hatches shut. On land, the storm was just as debilitating, though less lethal. A full blizzard raged across the entire region, with winds whipping the snow into a solid, impenetrable whiteout. Visibility dropped to absolute zero, making any form of travel impossible. Telegraph lines, the only means of communication at the time, were snapped by the weight of ice and snow, completely isolating lakeside communities. Cities like Cleveland and Buffalo were buried and paralyzed, but the true tragedy was playing out unseen on the raging lakes. With communication cut off, shore-based weather forecasters had no way to warn the ships still out on the water, and the captains aboard those vessels had no way of knowing the unprecedented scale of the monster they were sailing into. The toll on the Great Lakes fleet was catastrophic. Over 12 major ships were sent to the bottom, and more than 30 others were driven ashore and smashed to pieces by the waves. The stories of loss are harrowing. The steamer Charles S. Price was found floating upside down days later, a grim mystery as no one from her crew survived to tell what happened. The Henry B. Smith vanished with all hands after leaving port to escape the gathering storm, only to sail directly into its heart. Perhaps the most chilling tale is that of the whaleback freighter James Carruthers. This massive, state-of-the-art vessel, considered nearly unsinkable, simply disappeared without a single trace or distress signal, taking its entire crew of 22 down with it. In total, over 250 sailors lost their lives in those frozen, churning waters, leaving behind countless widows and orphans in the lakeside towns. The aftermath of the White Hurricane forced a revolutionary change in how North America viewed weather safety and maritime travel. The sheer scale of the disaster highlighted the critical need for better weather forecasting, more reliable communication, and improved construction standards for ships. It led directly to the expansion of the U.S. Weather Bureau's forecasting network and the establishment of more weather stations around the lakes. For the first time, the concept of a coordinated storm warning system specifically for the Great Lakes was taken seriously. The storm's legacy is a sobering one, a stark reminder that nature's most powerful events often occur where we least expect them, hidden from view until the moment they decide to reveal their full, terrifying power, rewriting the rules of safety and survival for everyone in their path. If the White Hurricane demonstrated nature's fury over water, the catastrophe that unfolded on the American plains just 2 decades earlier showed its power to turn the very earth against humanity. By the spring of 1935, the residents of the Great Plains were already living in a waking nightmare. Years of severe drought, combined with deep plowing farming practices that had destroyed the native, deep-rooted prairie grasses, had turned millions of acres of once fertile farmland into a barren, lifeless wasteland. The soil, devoid of moisture and anchor, had begun to literally blow away in a relentless series of dust storms that locals grimly called black blizzards. But nothing in their harrowing experience could have prepared them for the apocalyptic spectacle that arrived on the afternoon of April 14th. The day, which would become forever known as Black Sunday, began deceptively. After weeks of howling winds and blowing dust, a rare and welcome calm had settled over the region. For a few precious hours, the sun shone, birds sang, and families in states like Oklahoma, Kansas, and Texas dared to hope the worst was over. Some even ventured out to visit neighbors or attend church services. That fragile hope was shattered just after 4 in the afternoon. On the horizon to the north and west, a terrifying sight began to form. It wasn't a typical storm cloud, it was something far more sinister. Witnesses described a rolling, boiling wall of solid black, reaching from the ground up to heights of over 7,000 feet, more than a mile high. It was not made of water or snow, but of topsoil, sand, and grit. A churning mountain of the very earth itself, moving toward them at speeds of over 60 miles per hour. The sound that preceded this monstrous wall was described as a deafening roar, like 100 runaway trains, growing louder and more terrifying with each passing second. As the black blizzard engulfed towns and farms, it brought with it an utter and absolute darkness that was more complete than any night. This was not the gradual dimming of a sunset, it was a light switch being thrown on the world. In the middle of the afternoon, day turned instantly into a blackness so profound that people could not see their own hands in front of their faces. Chickens went to roost thinking night had fallen. Motorists were forced to abandon their cars, completely disoriented and blinded. The dust was so thick it seeped into every crack and crevice, coating the insides of homes with a fine, silt-like powder that covered furniture, contaminated food, and filled the lungs of every living thing. The immediate struggle was simply to survive the storm itself. Those caught outside risked being lost forever mere feet from their own front doors. Families huddled inside their homes, stuffing wet rags and towels under doors and around windows in a desperate attempt to keep the suffocating dirt out. But it was a futile effort. The static electricity generated by the colossal friction of the rolling dust cloud created terrifying phenomena. Barbed wire fences glowed with an eerie blue light, and simply shaking hands could produce a shock strong enough to knock a person down. The psychological toll was immense. In the impenetrable blackness, with the world screaming outside, many were certain the end of the world had truly come. When the storm finally passed after hours of terror, the landscape it left behind was unrecognizable. Fences, farm equipment, and even cars were completely buried under dunes of fine soil that looked like some alien desert. The ecological and agricultural damage was incalculable, snuffing out any remaining hope for that year's crop. Yet more than any statistic, Black Sunday served as a brutal turning point in national awareness. It was an Associated Press reporter walking through the dust-choked streets of Boise City, Oklahoma, who first used the term Dust Bowl in his dispatches. The phrase stuck, perfectly capturing the scale of this man-made ecological disaster. The iconic photographs and newsreels that emerged from that day of pitch-black skies at noon, of families fleeing with handkerchiefs over their faces, shocked the American public and finally galvanized the federal government into action. The legacy of Black Sunday is a complex tapestry of human suffering and environmental awakening. It was the worst single storm of the entire Dust Bowl era, but its immense symbolic power helped spur the creation of monumental conservation efforts. The federal government began programs to plant massive windbreaks of trees and to teach farmers revolutionary new techniques like contour plowing and crop rotation to conserve the soil. The event stands as a stark, sobering lesson in what can happen when human ambition clashes violently with the delicate balance of nature. A day the sky turned to dirt and the earth itself rose up to reclaim a land that had been pushed too far. While the Dust Bowl's black blizzards represented a slow-motion environmental catastrophe born from the land itself, the next event on our list arrived with the shocking, ferocious speed of a predator striking from the sea. In the final days of September 1938, much of the northeastern United States was enjoying a tranquil Indian summer. In New England, families were taking leisurely drives to see the first hints of autumn color, and fishermen were taking advantage of the calm weather. The U.S. Weather Bureau, the precursor to the modern National Weather Service, was tracking a tropical disturbance that had moved north from the Bahamas, but their forecasting capabilities were rudimentary at best. With no Hurricane Hunter aircraft, no weather radar, and limited communication between stations, forecasters believed the storm, as most do, would curve harmlessly eastward and spend its energy over the open Atlantic. It was a tragically fatal miscalculation. The hurricane, which would later be christened the Long Island Express for its incredible forward speed, had other plans. Instead of curving away, it was caught by a powerful, undiscovered high-pressure system to the north and a low-pressure trough to the west. This atmospheric steering mechanism acted like a slingshot, propelling the storm northward at an unprecedented velocity. It wasn't just moving, it was racing, accelerating to a forward speed of over 60 miles per hour. This meant that by the time the first warnings of a potential threat were being considered, the hurricane was already upon them. There was simply no time to prepare or evacuate. The express was living up to its name, and it was arriving right on time for a date with destruction. The first sign of trouble for most people was not the wind but the water. As the immense storm approached Long Island and southern New England, its counterclockwise winds began pushing a colossal wall of ocean water ahead of it. This wasn't a typical storm surge, it was a tsunami-like inundation. In westerly Rhode Island and along the Connecticut coast, the surge coincided perfectly with an astronomically high tide, amplifying its effects to a terrifying degree. Witnesses described seeing a dark, rolling fog bank on the horizon that quickly resolved into a solid wall of water, some estimates placing it between 25 and 50 feet high. This liquid avalanche swept across coastal communities with biblical force, smashing entire neighborhoods into kindling, lifting houses off their foundations, and carrying them inland with families still clinging inside. The wind that followed the surge was equally monstrous. With sustained winds well over 120 miles per hour, the storm qualified as a major Category 3 hurricane. But its incredible forward speed created a nightmarish additive effect. The actual wind speed pounding the landscape was the hurricane's intrinsic wind plus its 60-mile-per-hour forward motion. This meant the right side of the storm, where the winds were blowing in the same direction as its movement, experienced a devastating multiplier effect. On Long Island, the force of the wind was so extreme it physically pushed the water out of the Great South Bay, leaving the bottom exposed, only to have it all come crashing back in a chaotic, churning mess as the eye passed. The sound was universally described as a continuous, deafening roar, like 1,000 jets screaming overhead, drowning out all other noise for hours. The stories of survival and loss from that day are both heartbreaking and awe-inspiring. In the coastal community of Napatri Point, Rhode Island, a summer colony of 39 homes was completely obliterated by the surge, swept away as if they were never there. Dozens of residents who had chosen to ride out the storm perished. In downtown Providence, nearly 60 miles from the open ocean, the surge funneled up Narragansett Bay, flooding the city center under over 13 feet of water, submerging cars and the first floors of buildings in a churning, oily broth. Meanwhile, inland, the hurricane's winds unleashed a second wave of destruction. The saturated ground from recent rains could not hold the trees' root systems, and millions of trees were toppled, taking down every power and telephone line in their path and isolating hundreds of towns completely. Orchards were flattened and forests were left looking like a giant had thrown a tantrum, with trees piled in tangled heaps 20 feet high. The official death toll was staggering, with nearly 700 lives lost and over 600 people injured, though many historians believe the true number was higher. The economic damage was measured in the hundreds of millions of dollars, a catastrophic sum during the Great Depression. The aftermath was a scene of utter desolation. Miles of coastline were unrecognizable, landmarks were gone, and the collective psyche of a region was deeply scarred. The storm's legacy, however, was one of profound change. The utter failure of the forecasting system exposed critical weaknesses and sparked a revolution in meteorology. It led to increased funding for weather research, the establishment of more observation posts, and the beginning of a coordinated effort to track hurricanes and warn the public. The Long Island Express was a brutal, tragic teacher, but the lessons it taught about the ocean's power and the necessity of heeding its warnings would go on to save countless lives in the decades that followed. But just a decade after the Long Island Express rewrote the rules of hurricane preparedness, another storm would defy all expectations of what rain could actually do. Hurricane Camille is most famously remembered for its catastrophic landfall along the Mississippi Gulf Coast in August 1969, where its unimaginable storm surge and Category 5 winds obliterated entire communities. But as the remnants of this terribly powerful storm drifted northward, it seemed to be weakening, a typical fate for hurricanes moving over land. Forecasters expected a period of heavy rain for the Appalachian region, but nothing that would raise major alarms. No one could possibly foresee that Camille, even in its death throes, was preparing to unleash one of the most concentrated, furious downpours ever recorded on the North American continent. The stage for disaster was set by a perfect and terrible convergence of meteorological factors. The dying hurricane's immense circulation, still packed with a vast amount of tropical moisture, was being forced up and over the steep slopes of Virginia's Blue Ridge Mountains. At the very same time, it interacted with a nearly stationary front draped over the region. This combination acted like a massive atmospheric water pump. The mountainous terrain provided the orographic lift, forcing the humid air to rise, cool, and condense at an extreme rate, while the front prevented the storm system from moving away. The result was that the storm's entire reservoir of moisture was being wrung out over one tiny, unfortunate area with nowhere else to go. On the night of August 19th, the skies over Nelson County, Virginia, simply opened up. This was not a normal rainstorm, it was a seemingly endless torrential cascade. The rain fell with such intensity and volume that it transcended the very concept of weather and became a geologic force. In the small community of Davis Creek, a rain gauge measured an almost incomprehensible 27 inches of rain in just 8 hours. To put that in perspective, that is more than many major American cities receive in an entire year. The rainfall rate at the peak of the storm was estimated to be an inch every 15 minutes, a pace so relentless that the ground almost instantly lost its ability to absorb any water at all. The resulting flash flooding was apocalyptic in its speed and power. What began as small streams quickly became raging, unstoppable torrents of muddy water, trees, and boulders carving new channels down the mountain valleys. The water did not simply rise, it exploded through the narrow hollows with the force of a bomb blast. Eyewitnesses described a terrifying roar that grew throughout the night, a sound they initially mistook for the wind, only to realize it was the combined thunder of countless waterfalls and the grinding of entire landscapes being torn apart. For the residents nestled in these valleys, there was no warning and virtually no escape route in the pitch blackness of the stormy night. The devastation by sunrise was beyond belief. The landscape was utterly transformed, scarred by massive new gullies and blanketed in a thick layer of mud and debris. Entire families were swept away in their homes. Cars were buried under tons of silt and rock. The official death toll in Virginia reached over 150, with many victims never recovered, buried forever under the reshaped earth. The event stands as the United States record for the greatest amount of rain delivered in such a short period, a record that still instills a sense of awe and dread in meteorologists today. Camille's final, vicious act was a stark lesson in how the concentrated fury of a dying hurricane, when funneled by the right topography, can unleash a different kind of disaster altogether, one that falls from the sky not with wind but with an unimaginable weight of water. 2 years after the remnants of Hurricane Camille reshaped the mountains of Virginia with a deluge of biblical proportions, a different kind of atmospheric fury was brewing, one that would unfold not with water but with an unparalleled violence of wind. The stage was set across a vast swath of the eastern United States on April 3, 1974. The ingredients for a severe weather outbreak were all there, and forecasters knew it would be a bad day. But nothing in the history of modern meteorology, no model or experience, could have prepared them for the sheer scale of what was about to happen. This wasn't just a severe weather day, it was the dawn of the super outbreak, a catastrophic event that would see an entire generation of tornadoes born in a single, terrifying 24-hour period. The atmospheric setup was a perfect storm of everything that could go wrong. A powerful low-pressure system centered over Illinois was pulling a massive amount of warm, moist air northward from the Gulf of Mexico, creating a potent fuel source for thunderstorms. At the same time, an intense jet stream was screaming overhead, providing the critical wind shear that would turn ordinary storms into spinning, supercellular monsters. This combination of extreme instability and violent wind change with height created an environment where thunderstorms didn't just form. They multiplied, organized, and began producing tornadoes at a rate that was simply unimaginable. The first tornado touched down in Illinois shortly after 1 p.m., and from that moment the outbreak exploded, a meteorological chain reaction that raced eastward at a frightening pace. The statistics of the super outbreak remain mind-boggling half a century later. 148 confirmed tornadoes tore across 13 states, from Alabama and Georgia all the way north to Michigan and Ontario, Canada. The outbreak included an astonishing 6 F5 tornadoes and 24 F4s, representing a concentration of extreme violence never before documented. The tornadoes didn't follow a single line. They came in multiple waves, with families in some areas taking shelter multiple times throughout the afternoon and evening as new cells developed and spun up funnels. The map of the damage paths looks less like a weather event and more like a child had scrawled thousands of chaotic, overlapping lines across the entire Midwest and South. The human impact was devastating. Entire communities were erased. In Monticello, Indiana, an F4 tornado tore through the town, leveling entire blocks and claiming 19 lives. In Xenia, Ohio, the event reached its horrifying climax. Just after 4:30 in the afternoon, a single, massive funnel cloud descended on the western edge of the city. This was not a thin rope or a cone. Witnesses described it as a monstrous black wedge over a mile wide, blotting out the sky as it approached with a roar that drowned out all other sound. The Xenia tornado, rated atop of the scale F5, cut a path of absolute annihilation directly through the heart of the city. Schools were flattened, a freight train was thrown from its tracks, and entire neighborhoods of brick homes were reduced to bare foundations, the debris scattered so finely it looked like kindling. The stories from Xenia and other stricken towns are a harrowing mix of tragedy, miracle, and profound bravery. People who had seconds to react dove into bathtubs and closets, only to awaken surrounded by the wreckage of their homes. A school bus was tossed like a toy, yet the driver and children inside survived. The chaos was compounded by the timing. The outbreak happened on a weekday, meaning schools and businesses were full, and the sheer number of simultaneous tornadoes completely overwhelmed emergency response and warning systems. In total, the outbreak took 335 lives, injured over 6,000, and caused damage that would amount to many billions of dollars today. In the aftermath, amidst the shock and grief, a critical question emerged. How could this have happened? The event was so far beyond any previous understanding of tornado outbreaks that it forced a complete and radical reevaluation of the science of severe weather. Meteorologists pored over the data, realizing that the traditional tools and methods were utterly inadequate for predicting an event of this magnitude. The super outbreak became the single greatest catalyst for advancement in severe weather forecasting in history. It directly led to a massive expansion of the National Doppler radar network, as scientists realized the critical need to see inside storms to detect rotation before a tornado forms. It supercharged research into the dynamics of supercell thunderstorms and the precise environmental conditions that spawn such violent tornadoes. Perhaps most importantly, the tragedy in communities like Xenia, where warnings were issued mere minutes before impact, highlighted the desperate need for a better public warning system. The event galvanized the development of a more coordinated, nationwide severe weather alert process, eventually evolving into the modern integrated public alert and warning system we have today. The super outbreak of 1974 was a day of unspeakable loss, but from its rubble arose a new era of meteorological understanding and a renewed commitment to public safety, ensuring that the lessons learned from that terrible day would go on to save countless lives in the years that followed. Just when it seemed the atmosphere had exhausted its capacity for spectacle, a new kind of winter monster emerged from the Midwest, blending the violent energy of a summer thunderstorm with the blinding force of a historic blizzard. The first days of February 2011 saw a colossal low-pressure system begin to intensify over the Great Plains, a classic setup for a major snowstorm. But this system was different. It carried with it an unusually high amount of atmospheric instability for the heart of winter. As frigid Arctic air from Canada collided with an unexpected surge of warm, moist air rushing north from the Gulf of Mexico, the stage was set not just for snowfall, but for a convective explosion more typical of April than February. This clash of extremes would birth a storm that didn't just quietly blanket the landscape. It announced its arrival with a primal roar. The first reports came in from Chicago as the storm began to unleash its full fury on the evening of February 1st. Residents hunkering down for a typical, if heavy, blizzard were jolted by a sound they never expected to hear in a snowstorm: the deep, rolling boom of thunder. Outside their windows, the world was a swirling, chaotic mess of white, but periodically, that whiteout would be illuminated by a brilliant, silent flash of blue-white light that backlit the falling snow, followed seconds later by an earth-shaking clap of thunder. This was Thundersnow, one of meteorology's most rare and mesmerizing phenomena. It occurs when the same vigorous upward lift of air, the updraft, that creates summer thunderstorms happens in an environment cold enough for snow. The intense turbulence within the cloud generates electrical charges, resulting in lightning and thunder even as snow falls at astonishing rates of 2 to 3 inches per hour. For those experiencing it, the effect was profoundly disorienting and awe-inspiring. The acoustics of a heavy snowstorm are usually muffled. Snow acts as a natural sound absorber, creating an eerie, silent world. The thunder shattered that silence with a violence that felt out of place. The lightning, diffused and muted by the thick, snow-filled air, didn't appear as a sharp crackle, but as a sudden, silent flash that lit up the entire sky in a sustained, ghostly glow. This sensory contradiction, the summer-like fury of the sound and light paired with the winter chaos of the snow, created an almost apocalyptic atmosphere. It was a storm that engaged every sense at once, a full-body experience of nature's power that was both terrifying and beautiful. The impacts of the storm were monumental, with Thundersnow serving as the dramatic exclamation point on a record-breaking event. The lightning was a direct indicator of the storm's incredible intensity, marking the areas where snow was falling at its most extreme rates. These intense bands of thundersnow dumped snow in amounts that buried previous records. Chicago's O'Hare Airport recorded over 20 inches of snow, stranding thousands of travelers and bringing the third largest city in the country to a complete standstill. Ground and air travel was paralyzed for days, and the weight of the heavy, wet snow brought down trees and power lines, leaving hundreds of thousands without electricity in freezing temperatures. The Thundersnow blizzard of 2011 demonstrated that a winter storm could possess the raw, energetic violence of a hurricane, transforming a major metropolitan region into a silent, frozen, and momentarily powerless landscape under the eerie glow of winter lightning. If the Thundersnow blizzard showed winter's capacity for sudden, violent spectacle, the catastrophe that began brewing in the summer of 1993 would demonstrate nature's power to wage a war of slow, inexorable attrition. This was not a storm that arrived and departed in a matter of hours. It was a disaster that built its strength over months, a creeping inevitability that submerged an entire region of the country under a seemingly endless expanse of water. The stage was set by a persistent and peculiar weather pattern that locked itself over the Midwest in the early spring and simply refused to move. A massive high-pressure system, often called a blocking high, parked itself over the southeastern United States, acting like an atmospheric boulder in a stream. This stubborn high deflected the jet stream northward, forcing it to carry a seemingly endless train of moisture-laden low-pressure systems directly into the upper Midwest, week after week after week. The result was a season of relentless, repetitive rain. From April through August, town after town from North Dakota down to Missouri and across to Illinois shattered their annual rainfall records. The ground, already saturated from a wet fall and a snowy winter, could absorb no more. Every new downpour, no matter how light, had nowhere to go but straight into the countless creeks, streams, and rivers that all fed the mighty Mississippi and Missouri River systems. These two colossal waterways, the arteries of the American heartland, began to swell not from a single event but from 1,000 smaller ones. The rivers rose slowly, day by day, inch by inch, a terrifyingly gradual process that gave the disaster a surreal, slow-motion quality. Levees, both the massive federal structures built by the Army Corps of Engineers and the smaller, private berms built by farmers to protect their land, began to groan under the constant pressure. They were designed to handle a major flood, but not a flood that lasted for nearly 200 days. The human story of the Great Flood was one of exhausting vigilance and heartbreaking loss. For thousands of farmers and residents of river towns, the summer became a desperate battle against the rising tide. Sandbagging operations evolved from a community effort into a way of life. Volunteers and National Guard troops worked in sweltering heat and stifling humidity, filling and placing millions of sandbags in a futile attempt to add just one more foot of height to a threatened levee. The air was filled with the constant, low rumble of diesel pumps working overtime to push seepage water back over the barriers. Families lived for weeks with the terrifying knowledge that their home, their farm, their entire town could be inundated if just one section of one levee, miles away, decided to give way. The stress was immense and unrelenting, a psychological toll as damaging as the physical one, and give way they did. The flood's most iconic and devastating images came from these breaches. A levee would falter, often with little warning, and a jet of brown water would begin to spray through a sandbag wall or boil up from beneath the foundation. Within minutes, that jet would become a torrent, and then a catastrophic rupture, unleashing a tidal wave of river water across the farmland and communities it was meant to protect. The force was incredible, scouring the land down to the bedrock in some places and depositing layers of silt and sand thick enough to bury cars in others. Entire towns like Valmeyer, Illinois, and Rhineland, Missouri, were completely evacuated and then submerged for months, their streets transformed into canals navigable only by boat. The floodplain became an inland sea, at one point stretching over 700 miles in length and in some places over 10 miles wide, swallowing millions of acres of some of the world's most productive farmland. The final accounting was staggering. Over 9 states were declared major disaster areas, 50 people lost their lives, and the economic damage soared past $15 billion, making it the most costly flood in modern American history. Over 10,000 homes were destroyed and hundreds of towns were damaged. But beyond the numbers, the flood's true legacy was a profound shift in how the nation manages its rivers. In the aftermath, officials realized that the very system of levees designed to control the rivers had, in many cases, made the disaster worse by constricting the water into a narrower, higher channel and removing the natural floodplains that once safely absorbed overflow. This led to a revolutionary new policy, one that sometimes called for the deliberate breach of certain levees to save larger communities downstream, and more importantly, a move towards managed retreat, buying out properties on the most vulnerable land and allowing those areas to return to nature to serve as a pressure valve for the next great flood. The event proved that humanity's attempt to completely control nature could sometimes lead to a far greater calamity when nature finally decided to push back. While the Great Flood of 1993 demonstrated water's power to wage a slow, months-long war, a far more bizarre and sudden aquatic invasion struck the shores of Lake Erie just a few years ago, proving that frozen water could be just as mobile and destructive. In the final days of February 2019, residents along the New York and Ohio shoreline of the lake were experiencing a typical hard winter. The lake was almost entirely frozen over, a vast, solid plain of white ice stretching to the horizon. But on the morning of the 25th, a powerful low-pressure system began to intensify, funneling sustained winds of over 50 miles per hour straight down the long axis of the lake. These winds, blowing from the northwest, began pushing against the entire frozen surface, an immense force acting upon an unimaginable mass. The ice sheet, though several feet thick, began to crack and groan under the pressure, breaking into colossal pieces that would soon become instruments of unbelievable destruction. What happened next was not a wave of water, but a wave of solid ice. The relentless winds acted like a giant, invisible plow, shoving these massive ice floes, some the size of small cars or even houses, toward the southeastern shore. This was not a fast-moving event. It was a slow, inexorable, grinding crush that advanced at a pace of maybe a few feet per minute, but its power was absolutely unstoppable. Witnesses described a low, continuous rumbling and cracking sound, like the grinding of a million marbles, growing steadily louder as this white wall of ice, piled 10 to 30 feet high in places, began its relentless march inland. It didn't matter what was in its path. This ice tsunami, or as scientists call it, an ice shove, simply bulldozed everything. Homes that had stood along the shore for decades, providing peaceful views of the lake, were suddenly in the path of a force they were never designed to withstand. Walls splintered, foundations were cracked in half, and entire structures were lifted off their pilings and shoved inward, collapsing into piles of rubble as the ice pushed through them. Docks, boathouses, and seawalls were utterly annihilated, shredded, and incorporated into the growing mountain of icy debris. The event had a surreal, almost glacial quality to it, like watching a time-lapse of a moving iceberg, but happening in real time before the terrified eyes of property owners who could only stand by and watch, completely powerless to intervene. The conditions that create an ice tsunami of this magnitude are incredibly rare and specific. First, the lake must be almost completely frozen to create a single, cohesive sheet that can be pushed en masse. Second, there must be a rapid and significant rise in temperature to slightly weaken the ice, allowing it to break into large, formidable chunks rather than just crumble. But the most critical ingredient is a sustained, powerful wind blowing perpendicular to the shoreline for many hours without a shift in direction. This provides the constant, building pressure needed to overcome the immense friction and get billions of tons of ice moving. On that day in 2019, all of these factors aligned perfectly over Lake Erie, turning a dormant winter landscape into a scene of slow-motion chaos. In the aftermath, the shoreline was transformed into a post-apocalyptic landscape of jumbled ice blocks, splintered wood, and twisted metal. The damage ran into the millions of dollars. For scientists and residents alike, the event was a stark lesson in the raw physical power that can be stored in a frozen lake and unleashed with the right meteorological trigger. It was a dramatic reminder that even in a solid state, water remains a powerful and mobile force, capable of reshaping the land in ways that feel more like the work of ancient glaciers than a modern weather event. The ice tsunami stood as a bizarre and terrifying testament to the fact that sometimes the most dangerous storms are the ones you can see coming from a mile away, but are utterly helpless to stop. Imagine waking up on Christmas morning in balmy New Orleans or humid Houston, expecting a day of mild sunshine and perhaps a stroll outside. Now picture pulling back the curtain to find your entire world transformed, not by rain or frost, but by a genuine, silent blanket of white snow. This was the surreal reality for millions across the Deep South during the historic Christmas of 1989. A meteorological event so unexpected and so out of character for the region unfolded with a quiet, breathtaking intensity, turning the holiday into a scene from a dream and a logistical nightmare all at once. For a part of the country where a single snowflake can make headlines, this was nothing short of an atmospheric miracle. The driving force behind this bizarre holiday spectacle was a massive, stubborn dome of Arctic air known as a Siberian Express. This wasn't just a typical cold front, it was an immense reservoir of frigid air that plunged farther south than virtually any model had predicted. As this dense, cold air mass settled over the southeastern United States, it met with a separate weather system pulling abundant moisture from the Gulf of Mexico. The result was a perfect, if freakish, winter storm setup. The cold air was so deep and intense that it overrode the region's typical warm surface layer, allowing precipitation to fall as snow all the way to the coast. The event shattered countless records, with cities like Jacksonville, Florida, and Brownsville, Texas, experiencing their first measurable snowfall on Christmas Day, and places like Mobile, Alabama, seeing their snowiest Christmas ever recorded. The public reaction was a beautiful mixture of pure, childlike wonder and utter disbelief. In cities where snowblowers and ice scrapers were virtually non-existent, children and adults alike rushed outside in whatever they were wearing to experience the magical novelty. They built lopsided snowmen from the heavy, wet snow, had impromptu snowball fights on normally sunny beaches, and simply stood in awe as palm trees and Spanish moss became draped in a soft, white coating. The sight of historic antebellum homes in Georgia or the famous gas lamps of New Orleans' French Quarter, dusted in snow, created instantly iconic, almost surreal images that looked more like a movie set than reality. For many families, it was a once-in-a-lifetime Christmas gift from nature itself. Yet beneath the initial magic lay a harsh and dangerous reality for which the region was completely unprepared. The same snow that brought joy also carried a paralyzing sting. The South's infrastructure was simply not built for winter weather. Roads became sheets of invisible black ice, as municipalities had no stockpiles of salt or sand. The result was catastrophic gridlock and countless accidents on major interstates. The weight of the snow, heavy and wet, proved too much for tree branches and power lines not designed to bear such a load. Widespread power outages left hundreds of thousands of families without heat in plummeting temperatures, turning a festive holiday into a cold, dark struggle. Citrus farmers across Florida and Texas watched in horror as their crops, their entire livelihoods, were literally frozen on the branches, leading to agricultural losses in the hundreds of millions of dollars. The storm's legacy is a complex tapestry of awe and hardship. Meteorologically, it remains a benchmark event, a stunning example of how far polar air can intrude and how the right combination of moisture and cold can override even the most subtropical climates. It serves as a stark reminder that climate is not the same as weather. Even the warmest regions are not immune to freak, extreme events. For the millions who experienced it, the Christmas snow of 1989 is a story etched in memory, a tale they tell their grandchildren about the year a white Christmas came to the deep South, bringing with it a day of unforgettable magic and a sobering lesson in nature's unpredictable power. While tornadoes and hurricanes capture our collective imagination with their dramatic funnel clouds and swirling eyes, there exists another breed of windstorm that operates with a different, yet equally devastating kind of fury. If a tornado is a scalpel precisely carving a path of destruction, then a derecho is a warhammer delivering a wide, brutal blow that can shatter an entire landscape. This is precisely the terrifying reality that unfolded in the final days of June 2012, when a monstrous line of thunderstorms organized into one of the most powerful derechos ever recorded. A storm so immense and fast-moving it seemed to rewrite the rulebook on inland wind events in real time. The stage was set by a massive heat dome parked over the southeastern United States, pumping incredible warmth and moisture northward into the Ohio Valley. High above, a powerful jet stream raced along the northern edge of this hot air, creating an atmosphere brimming with explosive potential. On the morning of June 29th, a seemingly ordinary cluster of thunderstorms fired up over Iowa and northern Illinois. But instead of fizzling out as many summer storms do, these cells began to feed on the extreme energy in the atmosphere, organizing and strengthening at an alarming rate. They began to form a solid, bow-shaped line hundreds of miles long, a signature structure meteorologists recognize as the birth of a derecho. This particular bow echo began to race eastward at a breathtaking speed of nearly 60 miles per hour, a forward velocity that would become a key ingredient in the unprecedented damage about to be unleashed. As the derecho charged across Indiana and into Ohio, it transformed into a self-sustaining meteorological monster. The storm's own incredible power began to fuel its forward motion in a vicious cycle. Cold air rushing down from the storm's core, a phenomenon known as a downburst, crashed into the ground and spread out, plowing into warm, moist air ahead of the system. This collision forced the warm air upward, feeding new thunderstorms at the leading edge of the line, which in turn produced more cold downbursts. The storm became its own engine, a perpetual motion machine of violent wind. Radar imagery from that day showed a chillingly well-defined bow shape, with colors indicating wind speeds often associated with major hurricanes, painting a target across millions of people. The experience on the ground was one of sudden, overwhelming violence with zero warning. For many, the first sign was not the darkening sky typically associated with a severe storm, but an eerie, greenish tint to the air and an approaching roar that witnesses described as a continuous, deafening waterfall or a fleet of jumbo jets flying just overhead. Then the wind hit. This was not the gusty, swirling wind of a tornado. It was a straight-line hurricane-force blast that seemed to go on for 20, 30, even 40 minutes without a single moment of relief. The sustained nature of the assault is what made it so uniquely destructive. Trees, weakened by the prolonged assault, were not just stripped of leaves but were snapped in half or uprooted entirely. Power poles splintered and fell by the thousands, and transformers exploded in blue flashes that lit up the afternoon sky. The aftermath was a scene of staggering devastation that stretched from Chicago to the Atlantic Ocean. In cities like Fort Wayne, Indiana, and Columbus, Ohio, it looked as if a war had been fought block by block. The most crippling impact was the loss of electricity. The storm's widespread fury brought down the electrical grid for over 4 million people, and because the damage was so extensive across such a wide area, repairs took not days, but in some cases over a week. This occurred during a brutal heat wave, turning homes into ovens and creating a severe public health crisis for the vulnerable and elderly. The event was a harsh lesson in the vulnerability of modern infrastructure to a weather event that, until then, many had never even heard of. The 2012 derecho was a landmark event that forced a major shift in public awareness and meteorological focus. It demonstrated that a storm doesn't need to spin to be catastrophically destructive, and that the traditional language of severe thunderstorms was utterly inadequate to convey the threat of a coming derecho. In its wake, the National Weather Service began to refine its warning systems, developing better ways to communicate the specific, widespread danger of these wind events. The storm left a legacy of renewed respect for the raw power of straight-line winds, proving that sometimes the most dangerous weather is not the swirling vortex we are taught to fear, but the relentless, unstoppable wall of wind that gives no quarter and leaves an entire region in the dark. High up in the presidential range of New Hampshire, far removed from the sprawling derechos and hurricane coasts, stands a sentinel in the sky where the weather operates on an entirely different level of extreme. This is the summit of Mount Washington, a place so perpetually battered by the atmosphere's fury that it has earned the ominous nickname, home of the world's worst weather. And on one extraordinary afternoon in April 1934, the dedicated crew of the Mountaintop Weather Observatory didn't just experience bad weather. They measured a ferocity that would etch their names into the history books and set a record that would stand unchallenged for over 6 decades. The men stationed there were not mere observers. They were a rugged team of scientists and engineers living in a stone building chained to the rock to prevent it from being blown clean off the mountain. Their mission was to chronicle the brutal conditions firsthand, a task that required immense courage and a steadfast commitment to data. The stage for the record was set by a powerful low-pressure system moving up the Atlantic coast, colliding violently with a strong high-pressure system to the north. This dramatic clash of pressure created an unimaginably tight gradient, funneling the atmosphere's full force directly over the 6,288-foot summit. The winds had been howling for days, but on the afternoon of the 12th, they began to intensify into something truly otherworldly. Inside the observatory, the noise was a continuous, deafening roar that made conversation impossible. The very stone structure shuddered under the assault. The instrument used to measure the wind was a heavy, precision-made anemometer mounted on the roof. As the gusts grew more violent, the crew, led by observer Salvatore Pagliuca, knew they were witnessing something historic. They took turns braving the observation deck to ensure the instrument was free of rime ice that could impede its movement, a task fraught with incredible danger. Venturing outside meant being tethered to safety lines and crawling on hands and knees to avoid being instantly swept away into the void. Just after 1:21 p.m., the needle on the recording chart in the relative safety of the warm room made an unprecedented spike. The anemometer clocked a sustained wind gust of 231 miles per hour. To comprehend this speed, imagine standing in winds 3 times stronger than the threshold of a Category 5 hurricane, a force so powerful it exceeds the design specifications of most modern fighter jets for carrier landings. At that velocity, air ceases to feel like a gas and takes on the properties of a solid, fluid wall. The observers reported that the air itself seemed to boil, filled with a horizontal blizzard of ice crystals and snow ripped from the ground, scouring every surface with the force of a sandblaster. The record itself is a testament to both human fortitude and a near-perfect topographic accident. Mount Washington's cone-like shape acts as a natural accelerator for the wind, squeezing the airflow over its summit and increasing its speed dramatically. The persistence of the record for so many years is not due to a lack of powerful storms elsewhere, but rather the absence of a permanent, hardened weather station in those other extreme locations to reliably measure them. It wasn't until 1996 that an automated instrument in Typhoon Olivia off the coast of Australia finally recorded a 254-mile-per-hour gust, dethroning Mount Washington's measurement, though the New Hampshire peak still holds the record for the highest wind speed ever observed by human beings directly involved in its documentation. The legacy of that day in 1934 is about more than just a number on a chart. It is a powerful symbol of human curiosity and resilience in the face of nature's raw power. The men of the Mount Washington Observatory chose to stay and measure, to faithfully record the atmosphere's utmost extreme, providing a crucial data point that continues to inform and awe meteorologists to this day. Their achievement stands as a permanent reminder that some of the most profound discoveries happen not in the comfort of a lab, but on the front lines of the world's most unforgiving environments, where the wind doesn't just blow, it screams. Leaving behind the screaming winds atop Mount Washington, we travel to the opposite extreme of the weather spectrum, where the danger arrives not in a furious blast, but in a relentless tropical deluge. For much of the United States, January is a month defined by cold and snow, but for Southern California, it can sometimes feel like an extension of summer. That perception was shattered in a dramatic and devastating way in January 2005, when a meteorological phenomenon known as the Pineapple Express set its sights on the region. This isn't a single storm, but a powerful atmospheric river, a concentrated conveyor belt of moisture thousands of miles long, funneling vast quantities of warm, tropical water vapor straight from the Hawaiian Islands to the west coast. In this case, the fire hose was aimed directly at the densely populated hills and valleys of Southern California, and it was turned on full blast for an agonizingly long period. The setup was a classic and terrifying example of this pattern. A strong, persistent high-pressure system parked itself near Hawaii, acting as an atmospheric pump. To the east, a deep low-pressure system lingered off the California coast. The immense pressure difference between these two systems created a powerful and steady flow of air between them. This river of wind, flowing several thousand feet above the ocean surface, became saturated with moisture evaporated from the warm tropical Pacific. As this airborne current slammed into the steep coastal and inland mountain ranges of California, it was forced to rise rapidly. The rising air cooled, causing its immense cargo of water vapor to condense and fall as rain, not in gentle showers, but in a continuous, torrential downpour that lasted for days on end. The impact was catastrophic. The ground, already saturated from earlier rains, could absorb no more water. The hillsides, especially those scorched by severe wildfires just months before, turned into unstable slurry. The rain began falling on January 7th and continued with barely a pause for almost an entire week. By the time it finally relented, the Los Angeles basin had been pummeled by over 20 inches of rain, while some mountain locations recorded staggering totals approaching 30 inches. This was more than a year's worth of rain for some areas, delivered in less than 7 days. The relentless nature of the downpour meant there was no respite, no time for drainage systems to recover, and no chance for the sodden earth to hold. The most dramatic and deadly consequences came in the form of mudslides. In the affluent coastal community of La Conchita, the saturated hillside that loomed over the town finally gave way. With a deep, rumbling roar, a massive slab of earth over 300 feet wide detached and collapsed. This was not a slow creep of mud. It was a violent, fast-moving wall of saturated soil, rock, and debris that avalanched down the slope, engulfing everything in its path. In mere seconds, 15 homes were completely buried and destroyed. The rescue efforts that followed were desperate and heartbreaking, with crews digging frantically through the unstable muck in a race against time. Tragically, 10 people lost their lives in the slide, a grim testament to the sheer physical force unleashed by the liquefied earth. Beyond the landslides, the region faced widespread flooding of biblical proportions. The Los Angeles River, typically a largely concrete-lined channel, swelled into a raging, angry torrent, overflowing its banks and inundating neighborhoods. Streets became rivers, stranding cars and cutting off entire communities. The infrastructure was pushed beyond its limits. Sinkholes swallowed sections of road, and the flood control system, a massive network of dams and channels designed for exactly this scenario, was tested like never before. The economic damage soared into the hundreds of millions of dollars, a steep price paid for a weather event that delivered its destruction not with wind, but with the immense, crushing weight of water. The legacy of the 2005 Pineapple Express floods is a dual one of trauma and education. For scientists, it became a pivotal case study in the incredible power and persistence of atmospheric rivers, reinforcing the need for better forecasting and understanding of these rivers in the sky. For Californians, it was a brutal reminder of their state's precarious relationship with water, cycling unpredictably between punishing drought and catastrophic flood. The event underscored the critical importance of land management, especially in fire-scarred areas where the risk of debris flows remains high for years. This flood demonstrated that some of the most devastating weather events arrive not with a dramatic vortex or a screaming gust, but with the quiet, relentless, and ultimately overpowering drumbeat of rain on a roof day after terrifying day. Yet even the incredible downpours of the Pineapple Express could not rival the sheer, immobilizing power of a storm that arrived not with water, but with a suffocating, monumental weight of snow. In an era before modern weather forecasting, when the idea of a severe storm warning was little more than a glance at the sky, the East Coast was utterly unprepared for the cataclysm that descended upon it in March of 1888. The event would become known simply as the Great White Hurricane, a blizzard of such legendary ferocity that it didn't just disrupt daily life. It completely halted the entire machinery of modern civilization from the Chesapeake Bay to Maine, leaving a frozen, silent world in its wake. The meteorological setup was a perfect, devastating coincidence of opposing forces. A massive low-pressure system had developed over the Atlantic, just off the Virginia coast, and began to rapidly intensify. At the same time, a formidable high-pressure system was anchored over eastern Canada, pumping a vast reservoir of exceptionally cold Arctic air down into the New England states. The collision between the immense moisture of the coastal storm and this wedge of frigid air was catastrophic. The result was a cyclone of snow and wind that stalled for 2 full days, spinning counterclockwise and hurling unimaginable quantities of snow inland. The storm's most bizarre and dangerous feature was its temperature gradient. While New York City was buried under over 20 inches of snow with temperatures in the 20s, just a few hundred miles to the east, Nantucket was battered by wind-driven rain and vicious sleet. The experience for those caught in the storm was one of rapid, terrifying isolation. It began on a Sunday, March 11th, with unseasonably warm temperatures and rain. But by Monday morning, the rain had turned to heavy, wet snow, and the wind began to scream with a velocity that would eventually reach hurricane force. The snow fell at a rate of nearly an inch per hour for almost 2 full days, but it was the wind that transformed the storm from an inconvenience into a lethal event. It whipped the snow into a blinding, impenetrable whiteout, scouring the landscape and sculpting drifts that reached truly unbelievable heights over 50 feet in some places, completely engulfing 3-story homes and burying entire trains on their tracks. The world outside vanished into a swirling, roaring whiteness. The impact on transportation and communication was absolute. Above ground, every single railroad line on the eastern seaboard was shut down. Over 200 trains were trapped in the drifts, some for over a week, stranding passengers who were forced to burn the train's wooden furniture and even parts of the carriages themselves to avoid freezing to death. The elevated rail lines in New York City were frozen solid, their cars stranded high above the streets. Below ground, the newfangled telegraph system, the nervous system of the nation, completely failed. The weight of the ice and snow snapped thousands of poles, and the lines fell in a tangled mess, severing New York and other major cities from all communication with the rest of the world for days. For the first time, metropolises like New York and Boston were revealed to be profoundly vulnerable, cut off and utterly alone. The human stories from the blizzard are a stark mix of tragedy, ingenuity, and bizarre spectacle. An estimated 400 people perished, many of them found frozen solid only feet from their own front doors after becoming disoriented in the whiteout. Yet the storm also forged moments of incredible community. In New York City, the only way to navigate the impassable streets was on foot, and a network of ropes was tied between buildings to guide people, creating a surreal, ghostly web above the snowdrifts. Enterprising young men with shovels could earn a small fortune digging out the wealthy, while others built elaborate systems of tunnels connecting buildings, creating a temporary, hidden city beneath the snow. The legacy of the Great Blizzard, however, extended far beyond the epic tales of survival. The massive breakdown in infrastructure served as a brutal but effective wake-up call for city planners. The sight of decomposing horse carcasses and mountains of uncollected garbage revealed after the spring thaw exposed critical public health failures. In direct response, major cities like New York and Boston began the massive undertaking of moving their essential utilities underground. The blizzard directly catalyzed the creation of New York's subway system, designed to be immune to such atmospheric assaults. It also led to the burial of telegraph and telephone lines, ensuring that communication would never again be so easily severed. This monumental storm, in its terrible fury, didn't just paralyze the East Coast, it forced it to modernize, rebuilding its cities to be stronger, smarter, and more resilient against the next inevitable assault from the sky. While the Great Blizzard of 1888 showcased winter's ability to paralyze with cold and snow, a far stranger and more sudden thermal event unfolded over the plains of South Dakota more than a century later, proving that the atmosphere can sometimes behave like a rogue oven. In the early morning hours of July 26, 2011, most residents of the small town of Canastota were sleeping soundly. The night was warm and humid, a typical summer evening with temperatures lingering in the low 80s. A few distant thunderstorms rumbled on the western horizon, but they appeared to be weakening, drifting apart, and posing no threat. For anyone glancing at a thermometer around 2:45 a.m., there was absolutely no indication of the surreal and violent meteorological anomaly that was mere moments away from descending upon the town. What happened next defied all logic and sensory experience. In a matter of minutes, the sleeping town was jolted awake by a tremendous roar, a sound like a continuous freight train passing directly overhead. This was followed almost instantly by a blast of furnace-like wind. The air, which had been still and muggy, suddenly became a scorching, screaming gale, tearing through the area with enough force to snap tree limbs, topple sheds, and rip shingles from roofs. But the most bewildering aspect was the temperature. In the span of just 20 minutes, the mercury did not just climb, it exploded. Thermometers soared from a comfortable 80 degrees Fahrenheit to an astonishing and almost unbelievable 100 degrees. The National Weather Service station in nearby Montrose recorded this dizzying spike, confirming that the residents weren't imagining things. Their town had just been hit by one of the rarest and most bizarre weather phenomena on Earth, a heat burst. The science behind a heat burst is as counterintuitive as the event itself. It begins not with a building storm but with a dying one. On that night, the thunderstorms to the west were indeed collapsing. As a thunderstorm dissipates, it loses the powerful updraft that has been feeding it moist, rising air. Without this engine, the enormous mass of rain-cooled air within the cloud begins to sink rapidly towards the Earth. This is where the critical, strange ingredient comes into play. The air above the storm was exceptionally dry. As this heavy pocket of sinking air plunged downward, it entered a layer where the humidity was nearly zero. In this parched environment, any remaining raindrops within the air mass instantly evaporated. This process of evaporation requires heat energy, which it draws from the surrounding air, momentarily cooling it. However, as the air mass continues its rapid descent, it compresses due to increasing atmospheric pressure near the ground. Compression heats air dramatically, and because the air was now dry, having evaporated all its moisture, this heating effect was unimpeded. The result was a cannonball of superheated, desiccated air screaming toward the surface, hitting the ground and spreading out in all directions with hurricane-force winds and a shocking spike in temperature. For the people of Canastota, the experience was brief but terrifying and destructive. The intense winds, estimated to have reached 80 miles per hour, left a path of damage consistent with a small derecho. But the psychological impact of the sudden, oppressive heat in the middle of the night was perhaps even more jarring than the wind. People woke up sweating and gasping, their homes suddenly feeling like saunas, with hot, dusty air blowing through broken windows. The event was over almost as quickly as it began, the temperature gradually returning to normal levels over the next hour, leaving behind a stunned community surveying the damage under the eerie calm of the night sky. The 2011 Canastota heat burst stands as a perfect example of the atmosphere's capacity for paradoxical and localized violence, a reminder that even a storm's death throes can unleash a fleeting but spectacular burst of destructive energy. Yet even the bizarre heat burst that struck Canastota pales in comparison to the sheer global reach of a climate phenomenon that, in 1997 and 98, seemed to seize control of the entire planet's weather machine. This was the Super El Niño, an event of such monumental scale and power that it temporarily rewrote the rulebook for seasons across the Americas. demonstrating in spectacular fashion how an ocean temperature anomaly near the equator could send shockwaves through the atmosphere, triggering chaos from coast to coast. The stage was set in the vast expanse of the Central and Eastern Pacific Ocean, where a massive pool of unusually warm water began to develop, not just a few degrees above normal, but in some areas a staggering 14 degrees Fahrenheit warmer than average. This wasn't just a warm patch, it was an ocean heat engine of unprecedented size, pumping immense amounts of energy and moisture into the atmosphere, disrupting the very wind patterns that govern global weather. The first and most dramatic impacts were felt along the west coast, where the Pacific Ocean itself seemed to turn against the land. The abnormally warm water supercharged the jet stream, funneling a seemingly endless parade of potent low-pressure systems directly into California. These weren't ordinary winter storms, they were atmospheric rivers on steroids, fire hoses of tropical moisture aimed relentlessly at the state. The result was a winter of biblical rainfall and catastrophic mudslides. In Southern California, some locations received over 30 inches of rain in a single month, more than doubling their annual average. The ground, unable to absorb such a deluge, liquefied. In areas recently scarred by wildfires, like Malibu, entire neighborhoods were buried under devastating debris flows that swept homes off their foundations. The relentless waves accompanying these storms battered coastal cliffs into submission, causing multi-million-dollar mansions to teeter on the edge of collapse and wiping out iconic piers. The familiar sunny backdrop of California was replaced with a scene of brown, churning floodwaters and communities living under a constant state of emergency. While the West was drowning, the Southeast found itself in the crosshairs of a different kind of menace, one far more alien to the region during the winter months. The amplified jet stream, bulging northward under the influence of the El Niño, created a volatile mix of warm, moist air from the Gulf of Mexico colliding with lingering cool air at the surface. This combination is the classic recipe for severe thunderstorms and tornadoes, but it was playing out in January and February instead of the typical spring. The result was a series of devastating tornado outbreaks that tore across states like Florida, Alabama, and Georgia. Families preparing for a mild winter were instead forced into storm shelters as tornado sirens wailed. One particularly vicious outbreak in central Florida on February 23rd killed over 40 people and left a swath of destruction that made the Sunshine State look like it had been transplanted into the middle of Tornado Alley. The sheer number of winter tornadoes was a stark and deadly illustration of how El Niño could shift severe weather seasons and locations with terrifying unpredictability. Conversely, the northern tier of the United States experienced the Super El Niño in a strangely benign fashion. The same powerful jet stream that was bulldozing storms into California acted as a barrier, preventing cold Arctic air from plunging southward. Cities like Minneapolis, Chicago, and Buffalo experienced one of the warmest and least snowy winters on record. Ski resorts in the Rockies and the Northeast sat barren and brown, facing financial ruin as their season evaporated. In Alaska, the effects were even more profound and unsettling. The unusually warm patterns contributed to record low sea ice extent in the Bering Sea, disrupting ancient migration patterns for marine life and creating existential threats for indigenous communities that rely on the ice for hunting. The warmth in the north, while convenient for commuters, was a symptom of a deeply unbalanced system, a reminder that a respite from winter's bite could have dire consequences for ecosystems and economies built around the cold. The global ripple effects of this climate disruption were staggering. Peru, typically the first to feel El Niño's wrath, was battered by rains that transformed its coastal deserts into raging rivers, while severe drought and catastrophic wildfires ravaged Indonesia and Australia. The economic toll worldwide was estimated in the tens of billions of dollars. The 1997-98 Super El Niño event was a brutal but invaluable teacher. It provided scientists with a colossal natural experiment, offering a flood of data that revolutionized our understanding of ocean-atmosphere interaction. It showed with crystal clarity that our weather is not a local affair but a deeply interconnected global system, where a hiccup in the equatorial Pacific can dictate whether a homeowner in California is building a sandbag wall, a family in Florida is huddling in a closet, or a farmer in the Midwest is wondering where winter went. But even the global upheaval of a super El Niño cannot match the sheer atmospheric contradiction of a storm that is both tropical and frozen, a bizarre hybrid that seems to defy the very laws of meteorology. To find such an event, we must travel back to a time before modern forecasting, to October of 1804, when a tempest born in the tropics embarked on a strange and devastating journey that would leave the northeastern United States buried under a monumental and deeply puzzling layer of snow. This was the legendary snow hurricane of 1804, a storm so rare it has only been replicated a handful of times in the centuries since, an event where the warm heart of a hurricane somehow gave birth to a blizzard. The storm's origins were classic for a late-season Cape Verde hurricane, likely forming in the warm waters of the eastern Atlantic before tracking northwestward. It first made its presence known as a typical, if powerful, tropical system. In the days leading up to its arrival, it battered the Carolina coast with fierce winds and heavy rain, a standard threat for that time of year. But as it continued north, it began to interact with a much larger weather picture. A massive and unseasonably cold air mass was already entrenched over New England, a common occurrence as autumn deepens. The hurricane, still packing immense tropical moisture and energy, began to undergo a process known as extratropical transition. Essentially, it was being absorbed by the colder, larger mid-latitude weather system, but it was doing so in a particularly violent and unusual way. This collision of extremes created a meteorological paradox. The hurricane's core of warm, saturated air was violently lifted over the dense wedge of cold Arctic air. This forced ascent caused the moisture to condense and freeze with incredible efficiency. The result was not the cooling rain one might expect from a dying tropical system, but an explosive conversion of its entire reservoir of tropical moisture into heavy, wet snow. The storm's immense wind field, still carrying the circular momentum of its hurricane days, then whipped this snow into a blinding, furious blizzard. For the bewildered residents of New England, the experience was one of profound disorientation. The howling winds felt familiar, reminiscent of a nor'easter, but the sheer volume of snow was something entirely new and terrifying, a winter catastrophe arriving weeks ahead of schedule. The impact was catastrophic, particularly for a society utterly unprepared for a snowstorm of this magnitude in early October. The weight of the wet, heavy snow proved too much for trees that had not yet even shed their leaves. Branches and entire trunks splintered and crashed down by the thousands, destroying barns, blocking roads, and taking down every communication line in their path. Livestock, still grazing in open fields, were buried where they stood and perished. The snow depth was staggering. Contemporary accounts from Massachusetts describe accumulations of 2 to 3 feet, with drifts piling much higher. The economic damage was immense, devastating the autumn harvest and crippling transportation and trade for weeks. The storm's freakish timing and nature left an indelible mark on the region's collective memory, a story passed down through generations about the time a hurricane turned to snow. The legacy of the 1804 snow hurricane is far greater than its immediate damage. It stands as a foundational case study in the complex and sometimes counterintuitive behavior of our atmosphere. It proved that the ingredients for a major winter storm could be sourced directly from the tropics, that a system drawing its power from warm ocean water could ultimately be the catalyst for a historic snowfall. This event, and the few similar ones that have occurred since, like the perfect storm of 1991 which also produced snow, continue to fascinate and challenge meteorologists. They serve as powerful reminders that nature is not bound by our neat categorizations, capable of merging seemingly opposite forces, the humid fury of a hurricane and the icy grip of a blizzard, into a single, unforgettable spectacle of weather. Yet even these monumental clashes of air and ocean cannot prepare us for the kind of event that seems to warp reality itself, transforming a familiar landscape into a scene of surreal, swirling chaos. To witness such a spectacle, we traveled to the Sonoran Desert of Arizona in the summer of 2000, a season of typical, blistering heat. The desert floor, baked for months under an unrelenting sun, had become a vast reservoir of intensely hot air. On one particular afternoon, the conditions aligned not for one or two of the common, small whirlwinds known as dust devils, but for a full-scale outbreak of hundreds, a spontaneous generation of spinning vortices that turned the entire desert into a dancing, churning field of earth and sky. The atmospheric recipe for this phenomenon was both simple and extreme. A deep layer of scorching air just above the sandy surface created immense instability. The hotter air at ground level, being less dense, desperately wanted to rise. Meanwhile, cooler, denser air was moving in aloft, a necessary ingredient to create a rolling motion. As the hot air erupted upward in columns, any slight breeze or variation in the terrain, a rock outcropping, a dry riverbed imparted a spin, initiating a vortex. What made this day so extraordinary was the scale. The entire region was a uniform sheet of unstable air, meaning these vortices didn't form in isolation. They erupted everywhere simultaneously, a spontaneous army of spinning columns rising from the desert floor. The sight was something out of a dream or a special effects film. Across miles of open desert, hundreds of dust devils, ranging from slender, wispy columns to massive, roaring pillars over 1,000 feet tall, danced and swayed. Some moved erratically, collapsing after a few seconds, while others grew, merging with others or absorbing their energy to become true giants. They were not tornadoes, lacking the connection to a parent storm cloud, but their size and ferocity were nonetheless awe-inspiring. The larger ones were powerful enough to pick up not just fine dust and sand, but also small rocks, tumbleweeds, and any loose debris in their path, creating a visible, churning core of dark earth that snaked its way toward the sky. For the few residents and travelers caught in the midst of this outbreak, the experience was a mixture of wonder and minor peril. The sound was a constant, low, rushing noise, the collective sigh of the desert itself being stirred. Visibility dropped dramatically as fine particulate matter filled the air, and navigating the network of dirt roads became a hazardous endeavor as these unpredictable vortices would suddenly materialize and march across the path. While no single dust devil possessed the destructive power of a tornado, the sheer number of them led to a cumulative effect. Minor damage was widespread. Sheds lost their roofs, satellite dishes were twisted beyond recognition, and power was briefly knocked out to small communities as dirt and sand infiltrated electrical systems and shorted out transformers. The event, while temporary, left a profound impression on meteorologists and climatologists. It served as a stunning large-scale example of a process usually witnessed on a much smaller scale, providing invaluable data on how these whirlwinds interact with each other and their environment. For everyone else, the outbreak was a powerful reminder that the atmosphere holds an endless capacity for spectacle, capable of turning a quiet, sun-drenched desert into a breathtaking, chaotic ballet of spinning earth, proving that sometimes the most bizarre weather events are the ones that rise directly from the ground beneath our feet. Just as the desert whirlwinds of Arizona demonstrated nature's capacity for spontaneous, ground-up chaos, a different kind of atmospheric spectacle unfolded over the Pacific Ocean one summer evening, a phenomenon that moved with the deliberate, overwhelming force of a tidal wave. On the evening of August 16, 2010, residents and tourists along the San Francisco coastline were treated to a sunset that seemed utterly ordinary, with clear skies and mild temperatures. But on the horizon, something strange was brewing. A massive, smooth, and impossibly tall bank of white began to gather, not as a typical, wispy fog that creeps in on little cat feet, but as a solid, sharply defined wall that stretched from the sea surface thousands of feet into the air. Within minutes, this silent, looming wave began its relentless march toward the shore, a breathtaking and slightly eerie spectacle that would soon be dubbed the fog tsunami of San Francisco. This was not your average San Francisco fog. This was a textbook-perfect and immensely powerful example of advection fog, a specific type that forms when warm, moist air moves horizontally over a cool surface. The ingredients for this event had been assembling for days. A strong high-pressure system parked over the Pacific had been pushing a vast mass of humid marine air toward the California coast. Meanwhile, the ocean water just off San Francisco, chilled by the relentless upwelling of the deep, cold California current, was significantly colder than the air moving above it. As this warm, moisture-laden air mass made contact with the frigid ocean surface, the air at the very bottom was cooled to its dew point, causing its water vapor to condense into a thick layer of fog. The final, critical ingredient was a steady, strong wind pushing this newly formed fog bank directly toward the coastline at a rapid pace, preventing it from dissipating and instead stacking it into a towering, cohesive wall. The visual effect from the shore was nothing short of surreal. The fog bank appeared as a sheer, creamy white cliff face, advancing with a steady, silent inevitability that belied its true speed. It was so thick and well-defined that it completely blotted out the setting sun and the distant horizon, creating an illusion of a solid object moving across the water. As it reached the Golden Gate Strait, the narrow entrance to the San Francisco Bay, the physics of the event became even more dramatic. The constricting geography of the channel forced the massive volume of fog to accelerate, squeezing through the Golden Gate Bridge like a river through a canyon. This venturi effect caused the fog to pour into the bay with even greater speed and turbulence, cascading over the iconic red towers and quickly spilling down into the city's hills and streets. For those witnessing it, the experience was a rapid transition from a clear evening to an immersive, silent whiteout. The temperature dropped dramatically in a matter of moments, and visibility was reduced to just a few feet. The fog was so dense and cold that it immediately beaded up on every surface, leaving a slick, wet film on roads and sidewalks. The event was captured in stunning time-lapse videos by photographers who had anticipated the phenomenon, their footage showing the city's landmarks, the bridge, Alcatraz Island, the downtown skyline being utterly consumed by the rolling, boiling white wave in a matter of minutes. It was a powerful and beautiful reminder that even the air itself can behave like a fluid, capable of moving with the weight and force of a wave, reshaping a familiar urban landscape into a ghostly, silent dreamscape before receding back to the ocean as mysteriously as it arrived. Even as the silent fog tsunami of San Francisco demonstrated the ocean's power to shape the very air, an event of an entirely different nature, one of pure, ethereal light, was preparing to captivate the nation. For a few remarkable weeks in the summer of 2006, social media feeds and local news reports across the United States began lighting up with something extraordinary. They weren't pictures of severe storms or bizarre precipitation, but of the sky itself seemingly set ablaze with color. From Idaho to North Carolina, Texas to New Jersey, people were looking up and witnessing massive, brilliantly colored bands of light, appearing not as gentle arches like a typical rainbow, but as blazing, horizontal smears of spectral fire suspended high in the atmosphere. To the untrained eye, it looked like a piece of a rainbow had broken off and was floating parallel to the horizon, an event so stunningly beautiful and unusual that many were convinced they were witnessing a miracle, a sign, or something truly otherworldly. This widespread phenomenon, which quickly and poetically became known as a fire rainbow, possesses a scientific name that is far more descriptive, if less catchy: the circumhorizontal arc. Despite its fiery appearance and popular nickname, it has absolutely nothing to do with fire, and it isn't a rainbow in the meteorological sense. A true rainbow is created by sunlight refracting and reflecting through raindrops. The fire rainbow is something far more precise and fragile. It is a halo phenomenon, a spectacular optical illusion crafted entirely from light and ice. For this arc of color to manifest, a very specific and relatively rare set of atmospheric conditions must align with almost perfect symmetry. First, the sun must be very high in the sky at an elevation of 58 degrees or more. This requirement immediately limits sightings to the hours around solar noon during the late spring and summer months, when the sun climbs to its highest point. Second, a specific type of cloud must be present: cirrus or cirrostratus clouds, those wispy, feathery formations that ride 5 to 6 miles high in the sky where temperatures are perpetually far below freezing. But the true magic lies within those clouds. They must be composed of plate-shaped ice crystals, hexagons that have floated down through the thin air and oriented themselves almost perfectly horizontally, like countless tiny plates settling gently through the atmosphere. When the sun reaches that critical high angle, its light enters through the vertical side face of one of these flat, hexagonal crystals. Inside the crystal, the light is refracted or bent and then exits through the bottom face. This process acts like a prism, cleanly separating the sunlight into its individual component colors, the entire visible spectrum from red to violet. Because the crystals are all aligned horizontally by air resistance, this colorful light is projected en masse toward the ground, creating the illusion of a massive, flat, rainbow-colored band parallel to the horizon. The entire spectacle is a breathtakingly complex concert of geometry, physics, and perfect timing, a hidden masterpiece in the sky that only becomes visible when every single player is in its exact assigned place. The public reaction during the 2006 outbreak was a fascinating mix of awe, curiosity, and a touch of anxiety. In an age just before smartphones became ubiquitous, people rushed to grab their digital cameras to capture the phenomenon, with the images quickly spreading across early social platforms and internet forums. The sheer number of simultaneous sightings from so many different states was what made this event so exceptional. It wasn't that the atmospheric conditions were suddenly different. Rather, a widespread, stable weather pattern had settled over much of the country. A large ridge of high pressure created vast areas of sinking air, which helped form the necessary, widespread sheets of high-altitude cirrus clouds filled with those perfectly aligned ice crystals. For days on end, from the Rockies to the East Coast, millions of people were living under the ideal celestial conditions to witness this usually elusive light show. The result was a collective moment of national wonder, a shared experience that connected people from different walks of life through a common, beautiful mystery in the sky above them. For scientists and avid sky watchers, the outbreak was a magnificent opportunity for public education. They quickly worked to explain the science behind the spectacle, demystifying the fire rainbow while somehow making its true nature even more marvelous. They clarified that you're not looking at a physical object colored with pigment, but at a specific pathway of light, a brilliant projection on the celestial dome. The clarity and intensity of the colors depend entirely on the uniformity of the ice crystals. The more perfectly aligned they are, the sharper and more vibrant the band of light appears. This educational push helped transform the public's understanding from one of supernatural suspicion to one of scientific appreciation. People learned they weren't seeing an omen, but a catalog of sunlight, a demonstration of the hidden order and elegance within the apparent chaos of our atmosphere. The legacy of the 2006 circumhorizontal arc outbreak endures as a powerful reminder that not all of weather's most spectacular shows are born from violence or chaos. Some arrive in perfect, silent serenity, requiring no more than ice, light, and a precisely positioned sun. It showed that the sky holds wonders that can be explained by physics yet still feel utterly magical to witness. This event bridged a gap between mystery and understanding, proving that learning the science behind a phenomenon doesn't diminish its beauty, it deepens our awe, allowing us to look up and not just see a colorful light, but to understand the intricate crystalline dance happening miles overhead that makes it possible. But if the dazzling fire rainbow showcased the upper atmosphere's capacity for serene, crystalline beauty, then the phenomenon that gripped the interior of Alaska in the depths of the winter of 2013 revealed a form of wonder born from the most brutal cold imaginable. This was not a spectacle for a sunny summer afternoon. It was an event that could only unfold under a deep, silent Arctic night where the very air began to freeze solid. For weeks, a massive high-pressure system known as a Siberian dome had settled over the state, acting like a giant refrigerator lid that trapped a pool of incredibly dense, motionless air. Temperatures across the interior, in places like Fairbanks and the Tanana Valley, began a relentless plunge, bottoming out at 50, then 60 degrees below zero Fahrenheit. At these extremes, the ordinary rules of physics and weather begin to warp, and the air itself undergoes a startling transformation. The stage was set for what locals call a diamond dust blizzard, though the term blizzard is a profound misnomer. There was no storm, no wind, no falling snow. The skies were almost perfectly clear. Instead, the spectacle was generated from the ground up, literally from the breath of every person and animal and the scant moisture lingering in the desiccated air. In such intense cold, the little water vapor present cannot remain a gas. It instantly undergoes a process called deposition, bypassing the liquid phase entirely and freezing directly into billions of microscopic, six-sided ice crystals. These crystals are unimaginably small and lightweight, so much so that they do not fall from the sky. With no wind to blow them, they simply float, suspended in the frigid air, catching the slightest available light and reflecting it back in a billion dazzling points. To stand outside in this environment was to be immersed in a cloud of glinting, frozen glitter, a surreal experience of breathing in what felt like shattered diamonds with every gasp. The true magic, however, was revealed when a light source entered the scene. Whether it was the weak, low-hanging sun of the brief Arctic day or the artificial beams from street lamps and car headlights at night, these floating crystals became celestial artists. Each perfectly shaped hexagon acted like a tiny, complex mirror and prism. As light passed through them, it was refracted and reflected, creating a series of breathtaking optical illusions on a grand scale. The most common were immense, perfectly circular halos around the sun or moon, glowing with a soft, internal rainbow of color, but even more dramatic were the light pillars. When the crystals were oriented just right, they would reflect light from sources on the ground directly back downward, creating the illusion of towering, ethereal columns of solid light stretching from the earth up into the infinite blackness of the sky. A single street lamp could appear to be supporting a brilliant, shimmering pillar that reached to the heavens, a spectacle that felt both holy and utterly alien. For the hardy residents of Alaska's interior, the diamond dust was a familiar, if always awe-inspiring, winter companion. They understood it as the beautiful but dangerous face of the deep cold. The same conditions that created this glittering wonderland also posed a severe threat to life. Exposed skin could freeze in mere minutes, metal felt like it burned to the touch, and engines refused to turn over. The silence that accompanied the event was as profound as the cold. The world seemed to have been placed in a deep freeze, muffled and still, with the only sound the faint, crystalline crunch of the ice crystals underfoot. The 2013 event was notable for its persistence and the extreme low temperatures that fueled it, creating a prolonged period where the entire region seemed to be walking through a living, breathing jewel box. A stark reminder that even in the most hostile environments on Earth, nature reserves a capacity for creating moments of fragile, breathtaking beauty. While the diamond dust of Alaska painted the sky with ethereal light, an event of a far more ominous and visceral hue unfolded over the American Midwest just a few years earlier, casting the world in a sickly, otherworldly glow that signaled imminent and terrifying danger. On the afternoon of June 6, 2008, a powerful supercell thunderstorm began to brew over central Kansas. For residents in its path, the first sign that this was no ordinary storm wasn't the darkening clouds or the distant rumble of thunder, it was the light. The world around them began to take on a strange, surreal quality, as if someone had placed a vast, translucent green filter over the sun. The vibrant greens of summer fields and trees looked washed out and alien, while white houses and cars took on a distinct emerald tint. This eerie transformation wasn't a trick of the mind. It was a very real and scientifically explainable phenomenon, one that veteran storm chasers and seasoned Midwesterners had come to recognize as a dire omen, the arrival of a green sky. The science behind this chilling color shift is a fascinating interplay of light, water, and ice. Sunlight, as we know, is composed of the full spectrum of colors. As that light travels through the atmosphere, it interacts with molecules and particles, a process known as scattering. Our normal blue sky is the result of this. Blue light waves are shorter and scatter more easily in all directions than other colors. But inside a massive, mature thunderstorm, the rules change completely. These storms are incredibly deep and dense, packed with massive amounts of water droplets and, critically, huge hailstones. As sunlight attempts to penetrate the towering, lead-colored front edge of the supercell, the vast majority of it is blocked. However, a small amount of light manages to filter through the storm's core. This is where the magic, or rather, the menace happens. The blue light wavelengths, which are so easily scattered in a clear sky, are almost entirely absorbed or scattered away by the storm's immense thickness. What remains is primarily red light, which has a longer wavelength and can penetrate further. But that red light doesn't exit the storm alone. As it passes through the storm's core, which is laden with immense volumes of liquid water and large hail, it undergoes a process called selective scattering. The water droplets and hailstones, due to their size and composition, are exceptionally good at scattering the blue-green portion of the light spectrum. When this scattered blue-green light mixes with the residual red light that has managed to pass through, the result is a perceived hue of green. It's a specific, sulfurous shade that is not like the fresh green of grass, but more like the color of tarnished copper or an old bruise, a color that feels deeply unnatural and unsettling. For the communities lying beneath that ominous canopy in 2008, the green sky was more than just a meteorological curiosity. It was a non-verbal primal warning system. This specific shade is almost exclusively associated with the most powerful supercell thunderstorms, the ones capable of producing very large hail and, most significantly, strong to violent tornadoes. The ingredients needed to create the green hue, deep, rotating updrafts holding massive amounts of hail and water aloft, are the exact same ingredients that spawn the most dangerous tornadoes. The green sky, therefore, becomes a visible symptom of the storm's incredible intensity. As the light grew more lurid and the air became still and heavy, a deep-seated sense of dread settled over the region. People who had lived through it before knew to stop what they were doing, turn on the television or radio, and prepare to take shelter. The silence that often accompanied the green glow was perhaps the most frightening part, a pregnant pause broken only by the first blaring sirens. The psychological impact of this phenomenon is profound. The color green is not typically associated with immediate danger in the natural world. We link it with life, growth, and tranquility. To see the entire sky, the very source of light and life, transformed into a sickly, alien green triggers a deep, instinctual alarm. It creates a cognitive dissonance that is deeply unsettling, signaling that the normal rules of the world have been suspended. On that day in 2008, the warning was tragically valid. The storm system, fueled by the volatile atmospheric conditions that also created the green sky, went on to produce a significant tornado outbreak across Kansas and Nebraska. The eerie prelude of color was a stark, visible forecast of the fury that was about to be unleashed from the clouds, a haunting reminder that sometimes nature's most terrifying warnings are written not in words but in light. But if the green skies of the Midwest warn of a danger born from ice and wind, a different kind of colorful precipitation once fell over the American South, one that told a story of an immense journey spanning an entire ocean. In the summer of 2001, residents of Louisiana stepped outside after a passing shower to find their world subtly but unmistakably transformed. Instead of the clean, washed look that usually follows a summer rain, cars, houses, and sidewalks were streaked and spattered with a fine, reddish-brown film. It looked as if a thin layer of muddy clay had been sprayed across everything, leaving a dusty residue that was difficult to wash away. In a region accustomed to torrential downpours and hurricane floods, this was something entirely new and perplexing, a rain that didn't clean but dirtied, a phenomenon that would soon be explained not by local weather, but by a colossal storm blowing over the Sahara Desert thousands of miles away. This bizarre event, which quickly earned the dramatic nickname Blood Rain, was a stunningly clear example of how our planet's weather systems are deeply interconnected on a global scale. The explanation begins not over the Gulf of Mexico, but in the vast, arid expanses of North Africa. Every year, particularly during the summer months, immense dust storms known as haboobs roar to life in the Sahara. These are not minor sand squalls, they are towering walls of dust that can reach miles into the atmosphere, lifted by powerful convective winds. On this occasion, a particularly massive storm had kicked up billions of tons of fine silicate dust and mineral particles from the desert floor. This dust cloud was then caught by the prevailing easterly winds, specifically the African easterly jet, a river of fast-moving air that flows from east to west across the continent and out over the Atlantic Ocean. Once over the water, this immense airborne plume of Saharan dust began an incredible transatlantic voyage, riding the trade winds on a 5,000-mile journey that would take nearly a week. Scientists can track these dust clouds using satellite imagery, which shows them as vast, milky brown ribbons moving steadily across the blue Atlantic. This layer of dry, dusty air, known as the Saharan air layer, is actually a crucial feature of our climate. It plays a significant role in suppressing hurricane formation in the tropical Atlantic, as its dry, stable air inhibits the thunderstorm development needed for tropical cyclones to spin up. As the layer approached the Caribbean and the southern United States, it met with a typical summer weather pattern, a moist, rising air mass that was perfect for creating rain showers. This was the final, crucial step in creating the blood rain. As the moist air rose to form clouds, it incorporated the billions of dust particles suspended in the atmosphere. These tiny specks of Saharan soil acted as condensation nuclei, providing a surface for water vapor to condense around and form raindrops. Each droplet that formed was essentially a tiny ball of muddy water, encapsulating a piece of the African desert. When the clouds finally released their precipitation over Louisiana, they weren't just dropping water, they were delivering a rain of diluted mud, a direct atmospheric shipment of mineral dust that painted the landscape in faint shades of orange and red. For meteorologists and climate scientists, the event was a powerful and visible demonstration of a process that is constantly happening on a less noticeable scale. Dust from the Sahara is a primary source of nutrient replenishment for soils in the Amazon rainforest, providing essential phosphorus that fuels the growth of the lush jungle. It's a constant, silent exchange between continents mediated by the wind. For the residents of Louisiana, however, it was simply a strange day, a curious anomaly that left their cars dirty and provided a talking point for weeks. The 2001 blood rain served as a perfect, tangible reminder that a rain shower is never just a local event. It is the final step in a story written by the wind, a story that can begin in a desert storm a world away and end on the hood of your car, leaving behind the faint, dusty evidence of its incredible journey. After the silent, global journey of Saharan dust and the ominous green skies that warn of tornadoes, our next event delivers its message not through color or far-traveled particles, but through a sound that seemed to come from nowhere and everywhere at once, shaking the very foundations of homes and nerves alike. The winter of 2014 was already historic, remembered for the brutal polar vortex that had plunged much of the United States into a deep, prolonged, and record-shattering freeze. For weeks, temperatures across the Midwest and Northeast had remained locked in a sub-zero grip, a cold so intense it felt like a physical presence. But just as the worst seemed to be over and a slight moderation in the cold was expected, a new and terrifying phenomenon began to erupt. Starting in late January and continuing through February, emergency call centers from Illinois to Connecticut were flooded with reports that defied easy explanation. Residents described being jolted awake in the dead of night by a sudden, massive boom that shook their entire house, rattling windows and dishes. The sound was often compared to a cannon blast, a sonic boom, or even an explosion, and it was almost always followed by a distinct tremble that felt unnervingly like an earthquake. With no visible source, no flash of light, and no subsequent news of any industrial accident or construction blast, people were left frightened and deeply confused, their minds jumping to the most alarming possibilities. The explanation for this widespread disturbance was not found in the sky or in human industry, but deep within the frozen Earth itself, in a rare and dramatic geological event known as a cryoseism or frost quake. The stage for this epidemic had been set over the preceding weeks by the polar vortex's extreme cold. The ground, already frozen solid to a significant depth, acted like a lid. Then a sudden, slight shift in the weather pattern would occur. While the air temperature might only rise a few degrees, it was often enough to allow a brief period of sunshine or even a very light snowfall. This was the critical trigger. That small amount of precipitation or slight warming would melt a tiny amount of snow at the surface, allowing liquid water to seep down through cracks in the already frozen topsoil. But this reprieve was brutally short-lived. The deep, lingering cold of the Earth and the rapid return of frigid air temperatures would then flash freeze this water almost instantly. Water possesses a unique and powerful property. It expands when it freezes. This is the same force that cracks rock formations over centuries to create canyons, and that can burst water pipes in an unheated basement. In the case of the frost quake, this expansion happened with violent speed and was trapped within the confines of the rigid, already frozen ground. The water, now turning to ice, had nowhere to go. The tremendous pressure built up in a fraction of a second until the stress became too great for the surrounding soil and bedrock to contain. The ground then fractured explosively, releasing a massive shockwave of pent-up energy. That shockwave radiated outwards through the solid earth, causing the shaking people felt, and then traveled through the air as the terrifying, window-rattling boom that echoed across the quiet, frozen landscape. It was the sound of the planet itself cracking under the strain of the cold. For those who experienced it, the event was a masterclass in disorientation and fear. The randomness of the booms made them impossible to predict, and their intensity varied wildly. Some were faint, distant thumps that might be mistaken for a heavy truck hitting a pothole. Others were so powerful they were investigated by local law enforcement as potential bomb threats or suspected natural gas explosions. The psychological impact was significant, especially for people living alone or in rural areas. The lack of a clear, immediate explanation from authorities in the first few days only fueled anxiety. Social media became a crucial tool for collective sense-making, as people from different towns and states compared notes and began to realize they were not alone in their experience, slowly piecing together that the cause was linked to the unprecedented cold. The frostquake epidemic of 2014 was a stark and audible reminder of the immense physical forces that water and cold can generate. It demonstrated that extreme weather doesn't always manifest as a visible storm raging in the sky. Sometimes, its most dramatic effects are hidden underground, only announcing themselves with a single, shocking report. These cryosystems left no lasting craters or visible scars on the landscape, but they left an indelible mark on the memories of those who heard and felt them, a chilling testament to the fact that even in the deepest silence of a winter night, the natural world can suddenly break its silence with a sound of pure, explosive power. Hurricane Gloria's rampage up the East Coast in September 1985 is remembered for its fierce winds and battering waves, a classic and powerful autumn hurricane. But as the storm charged toward New England, it unleashed a meteorological surprise far from the coastline, one that defied the very definition of a tropical system. High in the Appalachian Mountains from North Carolina to West Virginia, residents who were preparing for a period of gusty winds and heavy rain instead witnessed something almost unheard of, a hurricane that was simultaneously producing snow. This bizarre convergence of summer and winter, of tropical moisture and Arctic chill, transformed Gloria from a standard coastal threat into a hybrid weather monster, creating a chapter in storm history that remains uniquely puzzling. The secret to this freak event lay in the complex atmospheric dance happening behind the scenes of the hurricane's main show. While Gloria's core of warm, saturated air was being pulled northward by the jet stream, a separate and powerful cold front was diving southeastward from Canada. This wasn't just a minor boundary between air masses, it was a deep, dense wedge of authentically frigid autumn air. As the hurricane approached the Appalachian Range, its immense circulation began to interact with this cold air barrier. The higher elevations of the mountains acted as a natural platform, lifting the colder, heavier air even further. This set the stage for a dramatic atmospheric handoff. The hurricane's incredible supply of tropical moisture was violently lifted up and over the dome of cold air. As it rose, it cooled rapidly, and the precipitation that formed in the clouds high above the mountains began as snow, falling through a deep layer of sub-freezing air that ensured it reached the ground as a wet, accumulating blanket rather than melting into rain. For the communities nestled in these high valleys, the experience was one of profound sensory dissonance. The calendar still reads September, a month associated with harvesting apples and lingering summer warmth, not with shoveling driveways. Yet, outside their windows, a heavy, wet snow was falling, clinging to trees that had not yet even begun their autumn color change. The weight of the snow on leaf-heavy branches proved too much for many, resulting in widespread snapping sounds that echoed through the forests as limbs cracked and came crashing down. The scene was surreal, a landscape of green leaves and white snow, whipped by winds that still carried the distinctive, humid feeling of a tropical system. Power outages were widespread, not from coastal flooding, but from the sheer physical weight of the snow bringing down power lines across the region. Meteorologically, the event was a stunning illustration of how fluid and unpredictable weather systems can be. Hurricanes are engines of heat, drawing their destructive power from warm ocean water. To see one effectively manufacturing a winter storm at the same time it was lashing the coast with hurricane-force winds was a moment that forced forecasters to reconsider the potential of these systems. The Gloria snow event demonstrated that a hurricane's influence is not confined to its eye wall or its rain bands. Its vast plume of moisture can be hijacked and transformed by other weather systems, creating entirely different types of hazards hundreds of miles inland from where the worst winds are blowing. This storm proved that the atmosphere is capable of blending its most extreme ingredients into a single, chaotic, and unforgettable event. But even the explosive shock of a frost quake deep within the Earth could not prepare the world for a celestial light show that arrived not from below but from the very edge of space itself. In the twilight hours of late June 2019, something impossible began to unfold in the skies over the western United States. As the sun dipped below the horizon, residents from as far south as Los Angeles and Las Vegas looked up and witnessed a sight so alien it seemed plucked from a science fiction film. High in the deepening blue of the upper atmosphere, wispy, electric blue tendrils began to glow with an ethereal, phosphorescent light. They looked like luminous, frozen cirrus clouds woven from pure energy, pulsing with a faint, internal radiance that grew more intense as the world below descended into darkness. This was not the gentle wash of the Milky Way or the fleeting streak of a meteor. This was a sustained, shimmering veil of electric blue, a phenomenon so rare at these latitudes that many who saw it had no name for what they were witnessing. They were seeing the rarest clouds on Earth, noctilucent clouds, and they were painting the sky 80 kilometers above the ground with a brush made of meteor dust and ice. The very existence of these clouds is a testament to the extreme and delicate nature of our planet's upper atmosphere. They form in the mesosphere, a layer so high and so thin it is practically considered the frontier of space. At this altitude, the air pressure is nearly a vacuum, and temperatures can plunge to negative 130 degrees Celsius, the coldest naturally occurring temperatures on the planet. In this frigid, hostile environment, the ingredients for cloud formation are almost non-existent except for two critical components delivered from beyond our world. The first is meteor dust. As countless tiny meteors vaporize upon entering our atmosphere, they leave behind a fine smear of microscopic dust particles suspended like glitter in the upper air. The second is water vapor, a surprising visitor to such a dry realm, which is believed to be propelled to these incredible heights by powerful atmospheric tides and even from the exhaust of space shuttle missions, which release large amounts of water vapor during launch. When these two ingredients meet in the deep cold of the summer mesosphere, the water vapor freezes instantly onto the meteoritic dust, forming ice crystals just a few dozen nanometers wide. It is these billions of tiny, high-flying ice crystals that catch the last rays of the sun long after it has set for viewers on the ground, scattering its light into that unmistakable, mesmerizing electric blue glow. The massive display of 2019 was a spectacular anomaly, a perfect storm of conditions in the upper air. Typically, these clouds are confined to latitudes above 55 degrees, making them a familiar, if always special, sight for observers in places like Canada, Scandinavia, and Siberia. For them to venture as far south as the 35th parallel, gracing the skies over millions of people who had never even heard of them, was an event of monumental rarity. Scientists pointed to a particularly active period of atmospheric gravity waves, ripples of energy moving through the air, similar to waves on the ocean that originated from powerful weather systems lower in the atmosphere. These waves propagated upward, acting like an elevator, pushing extra quantities of water vapor into the mesosphere and cooling it even further than usual. This combination of increased moisture and enhanced cold created an expansive, ideal canvas for the clouds to form over a much wider geographical area than normal. For the millions of casual stargazers and dedicated photographers who witnessed the event, the experience was nothing short of magical. Social media feeds were flooded with images of palm trees and city skylines silhouetted against these glowing, extraterrestrial-looking clouds. The sight sparked a wave of wonder and curiosity, with people rushing to explain the phenomenon to each other, sharing links and learning the term noctilucent for the first time. Beyond their stunning beauty, the 2019 display also served as a gentle, glowing reminder of our atmosphere's incredible complexity and its intimate connection with the cosmos. It was a visible signature of meteor dust from distant asteroids and comets intertwining with the breath of our own planet to create a fleeting, breathtaking work of art. This event proved that some of the most awe-inspiring weather phenomena aren't meteorological in the traditional sense at all, but are instead a beautiful collaboration between the Earth and the infinite space that surrounds it, a silent, glowing dialogue happening at the very edge of the sky. From the fire tornadoes of Ohio to the ice tsunamis of Lake Erie, from the hurricane snows of the Appalachians to the blood rains of Louisiana, this journey through America's most bizarre weather reveals a powerful truth. Our atmosphere is an endlessly creative, often unpredictable, and always awe-inspiring force. These events are far more than just historical footnotes or freak anomalies. They are powerful reminders of the immense complexity that governs our planet's climate system. Each one represents a moment where the delicate balance of temperature, pressure, and moisture was pushed to an extreme, resulting in a spectacle that challenged human understanding and, in many cases, forced a revolutionary leap in scientific knowledge. What ties these stories together is not just their strangeness but their profound impact. They are chapters in an ongoing story of discovery where human curiosity meets nature's raw power. The tri-state tornado taught us the terrifying potential of a single storm, leading to the advanced warning systems that save countless lives today. The Great Flood of 1993 showed the consequences of trying to bend rivers to our will, reshaping our entire approach to flood management. The Super El Niño of '97 was a crash course in global interconnectedness, proving that a warm patch of ocean near the equator can dictate weather patterns across the entire world. These events are the atmosphere's way of teaching us, sometimes gently, often harshly, about the rules it operates by. This incredible diversity of phenomena, from the deadly to the beautiful, underscores why scientific understanding is so vital. It transforms the terrifying boom of a frost quake from a mysterious omen into an understandable, if rare, geological process. It reveals the dazzling electric blue of noctilucent clouds not as an alien invasion, but as a breathtaking collaboration between meteor dust and mesospheric ice. With knowledge, we replace fear with fascination and superstition with wonder. We learn to see the world not as a chaotic and random place, but as an intricate, dynamic system where every event, no matter how bizarre, has a cause and an explanation waiting to be uncovered. The study of these events is a celebration of that wonder. It's a field that is constantly evolving, where a storm chaser's video, a satellite image, or a measurement from a mountaintop observatory can change our entire perspective. It reminds us that for all our technology and forecasting models, nature still holds the capacity to surprise us, to humble us, and to leave us utterly speechless with its inventiveness. These stories are a testament to the resilience of communities who rebuild, the dedication of scientists who seek to understand, and the simple, shared human experience of looking up at the sky and witnessing something you will remember for the rest of your life. Now we want to hear from you. Weather is the most universal of experiences, and everyone has a story. Maybe you've witnessed a sudden thundersnow event, seen a double rainbow after a summer storm, or have a family tale about a great blizzard from decades past. Share your own strange weather stories in the comments below. We read every single one. Your personal experiences are part of this incredible tapestry. And if you enjoyed this deep dive into the weird and wonderful side of our atmosphere, make sure to subscribe and hit the bell so you don't miss our next exploration into the fascinating world around us.